AI won't replace programmers, but rather make it easier for programmers to replace everyone else. When I learned to code in 2016, I didn't even know where to start. I ended up buying courses on Udemy, but I almost gave up because it was so long and boring. So in 2018, I ditched all the theory and instead built tiny internet businesses. Now in 2025, I have built 28 websites and I now earn $1.2 million per year as a solo developer. If I had to learn how to code again, I would do it completely differently. So in this video, I'm going to show you the exact roadmap to go from complete beginner to knowing how to code fast using AI. Okay, so this is the entire roadmap we're going to go through. It's divided into 3 parts. The first one is important you stick with me even though people make mistakes and skip it. It's the fundamentals of the internet. If you want to understand how to use AI to code fast, you need to understand how things work so you know what to tell the AI, you know what to search when you're stuck. In the second part, we're going to build a software business from scratch. I'm going to show you the tools I use to build my own software businesses. I'm going to show you how to set up your computer. We're going to talk about front-end, back-end, API, databases. We're going to send emails. We're going to process payments and all the things you need to set up a business on the internet. And finally, we're going to talk about how to use the modern AI tools in order to 10x your development process and code even faster. In the first part, we're going to cover the fundamentals of the internet. We're going to understand what it means for you as a developer to build an app that could be seen by millions of people across the world. It is very important that you stick with me for this part because later you'll see that 80% of your work will be done by an AI. And you just have to tell the AI what you want, but for that you need to understand how things work. You need to understand the foundation of the internet. So first, we're going to understand how the internet works as a consumer. You right now watching this video. We are browsing hundreds of websites per day, so you want to understand what actually happens when you go to a website. For that, you can just open ChatGPT and ask ChatGPT or whatever AI you're using to explain what happens when you visit a website. You want to mention that they should not explain using technical skills. You want to use like metaphors and things that are very simple for you to understand first. And here ChatGPT is doing actually a pretty good job at explaining. It compares searching for a website on the internet to sending a letter to the post office. Try to have like a little image in your mind of what is going on when you visit a website. When this is done, learn the fundamental concept of the internet. So go back to ChatGPT and ask ChatGPT to explain the same thing, the same journey, but instead, this time not using a metaphor, but using the actual terms that developers use, HTTPS, URLs, DNS, etc. There are 7 terms that I think are important for you to know. You don't need to know everything about it, but just try to have a clear understanding of what each of those is doing. As a quick example, this is me going to YouTube in New Zealand, and this is what the journey looks like. I'm on my internet browser and I search for youtube.com, so I'm considered as the client. When I press enter, my request is sent to my Wi-Fi, and then it goes basically on the internet. The internet is basically like a collection of devices that are somewhere across the planet. You have DNS, you have servers, you have a bunch of things, and the role of the internet is to find the right recipient for my request. So in my case, since I'm searching for youtube.com, it search for the YouTube server. The server is basically like a big online computer that is somewhere on the planet, likely in the United States in the case of YouTube, and this server is going to receive my request. And then it's going to send me back an HTML page using the same route that it took to come to the server. So it's going to go back to the DNS and the servers that are on the internet, and then it's going to come back to my computer. And then my internet browser, Safari, Google Chrome, whatever, is going to take this HTML page and display it so that I can actually see the YouTube homepage as a consumer. And now to jump to the next part, you can do something interesting. You can open the developer console. Search for your developer console. So here, developer tools, it's called on Google Chrome. And you can see on the right side, I have a bunch of stuff that might look like foreign language for you right now, but it's going to become much more clear soon. And we see that I have this like a body and head and HTML. Now, if I go to Reddit homepage and I open the developer console again, you see that I have this HTML head and body thing again. That is quite interesting. Actually, here what is going on is that everything on the internet that transits, whenever you're browsing as a consumer, you get HTML pages. And what you see here in the console, HTML head and body, is basically the structure of an HTML page, a web page. And so after this part, you will understand that your job as a developer is to build web pages and put them somewhere on the internet so that millions of people can access it across the internet. So let's build your first web page as a developer. We're entering the second phase. Now you need first to install a code editor. So there are 2 popular ones and actually many others, but there is a Visual Studio Code and you have also Cursor AI. To be honest, both are very similar. It really doesn't matter which one you choose. Both support AI features. I think Cursor AI at the moment I'm making this video has a plan for like $20 per month to have the AI features, and VS Code has a free plan for their GitHub Copilot AI feature. Once you picked your code editor, just open it and create a new file. Usually you can go to help and type file and you will see like new text file. Now we're gonna write your first web page. Remember, everything that transits on the internet, whether you're going to Facebook, Google, Instagram, no matter what, is a web page. So for that, we need to know what is the default structure of a web page. And so here our best friend is ChatGPT, so it can just say, what is the default structure of an HTML page? And then he's gonna send you back a similar piece of code. Just copy that code and go back to your code editor and paste it there. Then press Command S to save the file, and you can name it no matter what you want. I'm gonna call it homepage, and then make sure you keep the .html at the end, because a web page is a file, so it needs an extension, just like .mp4 is used for videos, .png is used for images, .html is used for web pages. So you can name it whatever you want, just add .html. You'll see that the structure of an HTML page is always the same. It starts with this little thing here, and then you have HTML tag here, HTML closing tag here, and then you have a head and a body, just like we saw on YouTube and Reddit before. And on top of that, ChatGPT already added a few information in this head and body tag, but we're gonna see that later. Okay, now you want to learn what you can add inside of a web page as a developer, the web page 101. And for that, I don't want you to just learn, I want you to build something, a real web page that you could show to a friend. That could be a portfolio, that could be a landing page for your idea, it doesn't matter, just think about something that you can show to a friend. And now any web page you see on the entire internet is made of three things: HTML, CSS, and JavaScript. If we compare this with a house, HTML is the foundation, the structure of the house. Without HTML, there is no house. We have CSS, which is used for styling to make your web page beautiful, the colors, etc. And we have JavaScript, which is used for user interaction and adding some dynamic parts to your page. So first we have HTML, which is the foundation of any web page. It is made with tags and attributes. So just like we saw before, this is written in HTML. You have here, a tag is this little thing here that when you see HTML, it is surrounded with brackets around it. And you always have an opening tag and a closing tag. And everything inside is like a children of this tag. And attributes like this are properties that you give to those tags. You'll see HTML is very simple. There are a few tags you want to learn, like for instance, links to be able to link between web pages, headings for titles, paragraph if you need to write a block of text, images of course, buttons, and inputs in forms, and containers if you need to wrap things around. You don't need to learn all the tags, just learn the very minimum. You can start writing the first version of your idea, of your web page, using HTML tags only. Then you can jump into CSS. CSS is basically a way to style your page, to make it more beautiful, to change the layout, etc. There are a few things that are important, like colors, layouts, padding, font size, etc. You don't need to learn everything. Once again, in the roadmap, you'll see there are a few CSS properties that you can learn that are important, but learn just enough to make a beautiful web page. And then finally, there is JavaScript. So JavaScript could be like a kitchen, a bedroom, a toilet, whatever. It has interaction, it adds features to your web page. For instance, when you click the like button under this video on YouTube, it will trigger JavaScript to do something. If you actually do like the video, that means a lot for me. JavaScript could be quite advanced. There are many things to learn. I would recommend to start with those foundations, the very minimum. For instance, you could have a button that when you click on it, it sends a little hello message somewhere on the page. And use that homepage.html file we created earlier to add text, to change the text color, add features using JavaScript no matter what. And whenever you're stuck with something, whenever you need to learn something, ask ChatGPT to help you around. Once you're done and you've saved your file, what you can do is you can open this file and view the results of your creation. For instance, now if I open this like homepage.html, if I double click, I'm going to go in my internet browser and it's going to display the things that I wrote with my code. And now you can do something even crazier. You can send that web page to someone. I'm just gonna go drag and drop it to my wife on WhatsApp, send the page to my wife, and now if she opens her phone and double click on this file, it will open her internet browser and she will be able to see the code that I wrote. And just like this, you have made your first web page. Now, of course, it is not available on the internet. There is no way for anyone across the world to access my web page, but you'll see that is very simple. We're gonna cover that in the next part. Okay, now moving on to part 2. Here, you're going to learn exactly what you need in order to build any internet business. Here, I said SaaS, short for software, but that can be a directory, that can be a habit tracker, that can be an AI tool, it can be literally anything. For instance, These are all the websites that I built. They're all very different. You have like a web analytics tools that I built, habits tracker that are made for people to track their reading and workout habits. I have built directories like this one where you have like thousands of pages indexed on Google. And I am using all the time the exact same roadmap that I will show you right here. So we're going to cover how to create landing pages, how to process payment, how to create user account, API database, front-end, backend, anything that you have heard of and that you think you need in order to build an internet business will be in this roadmap. The first step is to pick a tech stack. So this is the tech stack I use for absolutely all of my apps. In the programming language, I am using JavaScript. Some developers use Python or C or C++ usually for their backend, but mine only use JavaScript language. It's much easier. I don't have to learn two languages, just JavaScript. On the front-end part, which is what people are going to see, I'm using React, which is a JavaScript library to build reusable components like buttons and forms that my users can click on. I am using TailwindCSS to make writing CSS a little bit easier. I am using Daisy UI, which is a free UI component library. So it has a set of like predefined buttons and tables. So I don't have to design everything from scratch. And I am using NextJS as a React.js framework in order to organize pages. On the backend, which is the part that users don't see, usually the server, I am using two services. I'm using NextJS for the API. We're going to cover that later, but it's basically the invisible part where you do all your business logic. And I am using MongoDB for the database to store information. And I'm using some third-party tools in order to help me in my process. So for instance, for user authentication, login with Google, etc., I am using Auth.js. To send emails across the internet, I am using Resend. I am using Stripe and sometimes Lemon Squeezy to charge and process payments, so subscription, one-time payments, invoices, etc. And I am using DataFast as a web analytic tools to know, for instance, who visits my website. Okay, maybe at this point you're wondering like, what is going on to HTML, JavaScript, and CSS? What are we doing all of this? You'll see that even though the internet relies on web pages and everything you see on the internet is HTML, JavaScript, and CSS, as a developer, it is much faster to use those tools in order to write HTML, JavaScript, and CSS for us. Those tools are just meant to make our life easier. The tech stack I use right here is almost free for you to use. You see most of those tools have free plans, so you can get started with $0. And of course, if you don't like my tech stack, if you have heard of another tools that you prefer to use, it is perfectly fine. What is important here is that whenever you have decided what you're going to use for your tech stack, you want to stick to it and never change it. Because every time you have to learn a new tool, you're losing time on things that matters, which is shipping apps. And you will see that in the end, all those tech stacks thing, it's always the same debate. You can do pretty much anything you want with any tech stack. And finally, I want to mention that I am not sponsored whatsoever in here to make this video. None of those tools that you see here are paying me to make that. The only sponsor of this video is myself. I created this course called CodeFast to teach people how to learn to code quickly. It's a 12-hour course on the same principle as you see in this video. It's more hands-on because we're going to code along. Over 2,000 students have already learned how to code using the course, but of course, you don't need the course in order to learn how to code. You can learn by yourself using an AI and the roadmap I am going to show you right now. Okay, before we get started, you want to discover what the terminal is. If you go on your computer and you search for terminal, it is going to open a little app that looks like this where you can type command lines. It's basically a chat box to do stuff on your computer. So here, for instance, if I type pwd, it's going to tell me in which folder I am. I can navigate inside of folders like CD, and here I enter the desktop. There are very few simple commands like those ones, pwd, cd, ls, etc. that you can learn to help you later. You also have a terminal inside of your code editor. Now, if you go to the top and you search for terminal, you can pop up a new terminal directly inside of your code editor, which is going to be useful for later. And the reason we need a terminal at some point is because we're going to have some tools, developer tools running on our computer to make our life easier. And those tools usually need to be run using command lines in the terminal. Okay, now that we're good with the terminal things, we're going to move on and set up your computer to use all the tools we have from the tech stack. So first of all, you will need to install NodeJS. You'll find NodeJS as the first link on Google. Just click here and download it for your computer. It's not really clear for me when I started to code why I need NodeJS, so here is a quick example of why you need it. When you are on your computer, your internet browser, so Safari or Google Chrome, there is something called the V8 engine, which is the little background process that is running all the time and that is used to execute JavaScript. If you want to test your V8 engine on your computer, you can go to any website, you can open the developer console, and you can see that you can write JavaScript inside of the console here. And if I write alert name, is going to print, send me a little alert with my name. This thing here is able to run JavaScript thanks to the V8 engine that is coming already installed on your computer. And it allows us, developers, to write JavaScript inside of HTML pages. Now, Node.js, it's very similar to the engine, except that it can run on any computer, anywhere, anytime. That means now that you could start a little engine on your computer, not necessarily on internet browser, but like in the background on your computer, and you can run JavaScript from anywhere. So we're gonna use it for two things. We're gonna use it right now on your computer to set up all those developer tools and run them in the background. And you're gonna use it later automatically when we're gonna push your site on the internet. There will be some processes that are always running on the machine. We're gonna push your code so that it listens for like visitors coming to your site and is able to answer those requests. Okay, the second thing we need is to install NextJS. We're gonna use NextJS for two things, the front end, what people see, and the backend, what people don't see. Some developers use two completely separate frameworks for the front end and backend. I just find it easier to use NextJS for both of them. For the front end, for like web pages, things that our visitors are going to see and use, you remember from the previous section of this video that we have .html files that are able to be shown somewhere on your internet browser. But you'll see that with NextJS, we're not going to write HTML directly, we're going to write JavaScript. And then on your computer, there will be a process that will turn this JavaScript into an HTML files that we're going to send back to visitors so that they can see your creation on their internet browser. And this process that will turn the JavaScript into HTML is using behind the hood Node.js that we just downloaded. And for the backend part with Next.js, it is using serverless, so we won't have to manage an entire instance or machine and put it on the internet. This will be done automatically for us, so we won't have to think about that. But don't worry about that, we're gonna go deeper later. And finally, if you haven't done it from the previous lesson already, you want to install a code editor like VS Code or Cursor. Okay, now we need to install Next.js, the framework that we're going to use to show pages to our customers, so the front-end part, but also as the backend, the server, so the thing that is invisible to customer, where we're going to have our API and database logic, etc. Some developers prefer to have two separate projects for their front-end and their backend. I just find it easier to use just Next.js for both the front-end and the backend. So to install Next.js, just go on Google, search for Next.js, and take the first link that you see. You'll see this little command line written right here. Just copy that and open your terminal. Just before you pass the command here and press enter, make sure you are in the right folder because it's going to create a Next.js project. So for that, I am going to navigate to my desktop on my computer and I'm going to go inside of the Node.js workspace. This is exactly the same as if I were going to click here on the desktop and open this Node.js workspace. So now that I am inside of the Node.js workspace, I can pass the command and press enter. So quick breakdown of the command here, this npx thing now is available because we just downloaded Node.js. So we have access to this command which is going to execute something. The something we're going to execute is this command here, create next app, which is something that the Next.js team has created to create an entire project right on our computer. And the @ and latest right here just mean that we want to use the latest version of this program, so we have access to the latest feature. It's not a big deal, but it's better you just copy paste it the way it's given. Here it's gonna prompt you with a bunch of questions. So you press Y to proceed. I'm gonna name my project Unicorn. I am not going to use TypeScript. Yes for ESLint. Yes for TailwindCSS. We don't need the src directory. Yes, we need the app router. Yes, we need TurboPack. And we don't need to customize the import alias. Once you press enter here, it is going to set up something on your computer and you will see that on the left side in this folder, there'll be a new folder that is created that I named Unicorn. And this Unicorn folder will contain all the Next.js file. The project was successfully created, and now if I visually go to my Unicorn folder, you'll see that I can actually see all the new files that were added. So all of those files here were created during the command line script that we executed just before. And finally, if you haven't already from the previous lesson, you want to download a code editor like VS Code or Cursor. Okay, now open your code editor and open the folder we just created. So for me, it's in my desktop. NodeJS workspace, and then unicorn. Now you see on the left side, I have all the files and folder that were created automatically for me. There's a bunch of stuff going on here, and this is going to be your workspace basically as a developer. So we need to understand and break down a little bit of what is going on. So there are multiple things here that are going on inside of this project. The first one, and a very important one, is the package manager. We now have access to NPM. NPM stands for Node Package Manager. It's basically a directory of modules of packages that we can use from the internet. So for instance, there are developers who create really cool libraries like a date picker, a nice form, or this like a component library that we're going to use later in the project. But there's a bunch of components that were already made and are available for free, and you can just download it. Here, for instance, the command to download this entire package with all those components is npm I, short for install, daisy UI. And if you run this command inside of your terminal, you will have access to all those components inside of your own project. Actually, if we go back to the project and you open the node_modules folder, you'll see you already have a bunch of packages that were installed already for you. You can actually see a list of all the packages that we have installed. They're here inside of your package.json is like a controller of all the list of packages that we have installed. They're here in the dependencies or the dev dependencies. Here we have React, React DOM, and Next. And sometimes those packages relies on other packages which rely on other packages. That's why we have like an array of packages. So here we only have a few packages, but you have thousands, maybe 100 packages here in the node modules is because some of those ones here rely on more packages. And whenever you install a new package, it's going to appear somewhere here in this package.json file. So now I'm going to open a terminal inside of the code editor. So I am already inside of my project. And if I want to install a new package, I just have to type npm install and the name of the package. And another part that is important in your package manager is that you can run scripts using the npm run script name command. So let's go back to the project. Here we see in the package.json, you have already 4 scripts. And the first one, the dev script, is one that we're going to use a lot. To run a script, npm run and the name of the script. Now when I press enter, it's going to execute this command. This is something that was created by the NextJS team and is going to set up my computer to run a little development server so that I can write and compile code. Here it tells me to go to localhost 3001. It's because I already have another script running, but for you it's likely localhost 3000. So just copy or follow this link. Go to your internet browser and press enter, and you should see right here a little website that is now on your computer. So as a quick recap about the Node Package Manager, now on your project, you have access to a few commands. You can install or update packages, which are like tools that were created by other developers that will help you in your programming journey. And you can run scripts, which are going to do stuff on your computer, which is going to execute something on your computer, like the one we just run, npm run dev, where we are setting a local development server to make your website. Right, the next part that's important for your project is the version control system. I might get canceled by real software engineer for putting GitHub and Git inside of the same topic here, but roughly those two services, Git and GitHub, will help you do a bunch of things. On one hand, you have Git, which is going to help you make versions of your code. So for instance, you push a new feature or you fix a bug, you create a new version for your code. And so that later, if you realize you made a mistake, you can revert back to the previous version. It helps you organize your code. And GitHub is like a Google Drive for developers where you're going to push your code, what you write on your computer, you're going to push it on the internet in GitHub. It's a free service and we're going to push all of our code out there. So in case you lose your computer, you can still download your code from GitHub. Later on, you'll see that we'll have something connected to GitHub, and then whenever GitHub has a new change, a new code that is being pushed, is going to deploy our change to our actual website. Okay, first let's start with Git. And just a few things here, those 3 commands, git add, git commit, and git push, you don't need to memorize them, but basically they're inside of your code editor. They're, whenever, for instance, I press the plus button, I stage the change, it is the same thing as if I type git add dot inside of my terminal right here. Those 3 commands are the ones you're going to use the most, but technically you won't have to write them because, well, your code editor has a interface for you to just type buttons, so you don't have to write those commands. And finally, there is the .gitignore file, which is already installed in your project right here on the root side. If you open it, you'll see a bunch of words and things here. Each line is basically one thing to ignore. So we don't want Git to track those files or folders. For instance, the /node modules, which is this one right here. There's like a massive folder of modules that we've talked about earlier. We don't want Git to track this because those are dependencies. This is not code that we write as developers. Those are just packages we installed, so we don't need to track this inside of Git. Normally, you won't have to touch the gitignore file, but just in case, you know that anything that is in here will be ignored by Git and therefore won't be pushed to GitHub. To install Git on your computer, go to those three dots on the left and click Download Git for your Mac. Follow the link they tell you. And here, if you are a Windows user, you're lucky, it's very simple. If you're a macOS user, we need to install Homebrew first. So click the Homebrew link and then install Homebrew, copy paste that command line and open your terminal. Just paste that command into your terminal and press enter. It's going to go on the internet and install the it's not a software, it's like it's similar to NPM, the package manager we talked about previously for Node.js, except that it's for your entire macOS system. To complete the Homebrew installation, we just need to copy paste the lines of code they tell us. So copy the first one, paste it into your terminal, press enter, and do the exact same thing for the second one. Now that you're done, you can go back to the Git installation page and copy paste the command homebrew install Git and paste it into your terminal. Press enter, it's going to install Git, and then a few seconds later, you should be done. You'll need to restart VS Code, so go to VS Code, close the application, and then restart the application again. Open the repository we were working on, and then go back to the three dots thing and click Initiate Repository. And here you're going to see the list of all the files that were changed in this project, and we're going to go over that very soon. Whenever you're done coding a little feature for your application, or maybe like fix a bug, you want to create a new version using Git. For that, you're going to use Git commit quite often. To make a commit, you will have to go on the Git part of VS Code, so the little three dots at the top left, and then you would have to write a message. Usually you would write something that is explicit, for instance, added this feature or fix that bug. In this case, we're just getting started, so we're going to write first commit. And the message is only for you later to remember. Press commit, and you're going to see a little error message. It's because we need to set up Git for your computer for the first time. And if you scroll in the error message, you will see that there are two missing things we have to run. Git config global, you need to set up your email and your username. This is not going to log you anywhere. It's not on the internet. It's just purely staying on your computer, just so Git knows who is the user who makes those changes. So you don't even have to write your actual email. You can write anything you want. Copy paste those lines of code. Go to your terminal, paste the command there. Eventually update the email or the name if you want. Press enter. And then click commit again. And boom, here we go. You've made your first commit. Now you've created the first version of your app, it would be great if your code was stored somewhere on the internet so that if you lose your computer or if you work with other developers, they can access it or you can access it from another computer. And for that, we're going to have to use GitHub. So when you click Publish Branch, it's going to ask you to sign up for GitHub. You'll have to create an account, this time with a real email. So sign up with whatever you have as your primary email, finish the GitHub tutorial, like sign up entirely, and then go back to this course. All right, so now you're signed up to GitHub. It's basically some kind of like a Google Drive for developers. The code you write on your computer can be pushed on GitHub, so it's online and either other developers can use it or you can use it with other computers. So now go back to VS Code and you can click Publish Branch. It's going to ask you again to sign up with GitHub. This time you have an account, so you can just authorize VS Code to access your GitHub account. And it's going to reopen VS Code for you. And here, select the Publish to GitHub private repository. And after a few seconds, your project will be pushed on GitHub. Now, if you go to your GitHub profile, you can see the repository, your project with the entire code that we've been writing on your computer. Okay, another tool that is going to make your life much easier as a developer is called the linter. The linter we use in our project is called ESLint. If you open your project, if you go to whatever file you want, and let's remove, for instance, this little line here, you can see that I have a red color and it says JSX element has no corresponding closing tag. It's because in the background I have this linter called ESLint that is analyzing my code all the time, and whenever I make some typo or whatever I write code that should not exist, it's going to try to tell me where the error is and how to fix it. And now they even connect it with AI, so I can actually just click here and ask the AI to fix it in the composer for me. If you ever need to customize some of the rules and how it behaves, you would search for ESLint somewhere in your project and you could customize some of the behavior of the linter. Okay, and finally, let's have a quick look at the NextJS project architecture. So you see now we have a big folder with a bunch of files and a bunch of folders. Inside of the app folder is where you're going to write most of your code. You're going to create new pages, you're going to create components, etc. Inside of the public folder is where we're going to put some like files and icons, things that we want to be available anywhere on the internet. And then you have a bunch of other files. We have the package.json that is kind of like the controller of our app. You have a configuration file for Next.js. You have your gitignore file. You have your lint file as well. Those are more like controller files. Now you might be wondering like, well, Mark, previously, we used HTML to make a simple web page that I can send to my friend and they can see it. And now we have all those things with like different type names and extensions and folders, etc. Where is my HTML file? So this is what we have done before. We created an HTML page, we send it to a friend, it opens their internet browser, and they can see what you have created. And anywhere you go on the internet, no matter what website you visit, you're going to receive HTML, JavaScript, and CSS. But the problem is, as a developer, if you were to create an entire website using just pure HTML, JavaScript, and CSS, it would be kind of tedious and kind of boring, to be honest. That's why developers have created frameworks and libraries around it to write in a different language that is faster and easier to write, and instead is going to turn what we have created, what we have coded, into actual HTML, JavaScript, and CSS. So this is exactly why we have a Next.js project. Instead of writing HTML, we're going to write JavaScript. The .js stands for .javascript, meaning the file will be written using JavaScript language. We're going to use libraries like React to write even faster, and Next.js is going to compile our code into valid actual HTML, JavaScript, and CSS. So there are three main components here. The programming language we're using is JavaScript. On top of it, we have React.js as a JavaScript library. It's going to give us a set of tools to do things faster. So for instance, we can create reusable components. So for instance, we can create a button that shows a little message using React, and we can reuse that exact same component at many different areas into our app. So this is going to make our life much easier. And finally, on top of this, we have NextJS, which is a React.js framework, which is going to help us organize all our code and also going to compile all the code we write and turn it into actual HTML, JavaScript, and CSS so that anyone in the world with an internet browser can see and use our app. All right, one last thing about breaking down the actual project. You know, there are bunch of files here. You're not really yet sure of how those files interact with each other, but don't worry, the goal here with this video is to show you really the minimum you need to know in order to turn your idea into an actual project. So we're gonna jump into the coding as fast as possible. And only later, when you will need to customize a few things, you will learn by yourself what each of those files are needed for. And since now AI is here to help us developers build stuff but also explain stuff, I recommend you to start setting up your AI copilots in your code editor. So for Cursor, the one I use myself, it is already here. If I press Command L, it's going to open a chat window with an AI. I think if you're using VS Code, you will have to add a little extension. Like here, you would have to search for GitHub Copilot. It really depends on your code editor. Just search it on Google, you'll easily find it. One of the first use case of AI, which you can use even before starting how to code, is to explain what you don't understand directly inside of your code base. So for instance, here, I just set up this project. I am new to Next.js. I don't understand every single of those files. What I can do is I can just type English and I can ask my AI, what is the app folder, this thing here, used for? And then you'll see that the AI is actually really good at explaining things for me, so I have a clear understanding. I can also refine my prompt and explain me using metaphors. I can ask it to explain it in my own language, in French if I want. You can really use these AI chats to explain you what every single part of the code is for. Okay, theory is kind of boring, so now it's time to jump into the part where we're gonna actually code something. We're gonna build a landing page. A landing page is basically a single static page where you can introduce your idea or you can showcase your skill, like your portfolio page. What I want you to do here is to actually build something for yourself. Even if it's a very simple website, just build something along with me, because later we're gonna deploy it on the internet and you'll be able to send your website to anyone and they will be able to access and visualize and see what you have created. There are three parts when it comes to creating landing pages. There is React, NextJS, and TailwindCSS. Okay, first we need to start a development server. So pop up your terminal, Command-Shift-N as a shortcut, and write npm run dev. Press enter, and it is going to start a local development server. Now to view the project, I can just go to http localhost 3000. I'm going to copy that link, and I am going to my internet browser, paste the link here, press enter, and then I can see my actual app. And so now whenever you make changes inside of the code, this little script here is going to rerun this page and you're going to see the latest changes. So for instance, if I were to add a yo right here, you can see that now my localhost 3000 website is showing what I just wrote. Okay, the first and probably the most important part is React. It's the most popular JavaScript library used to build user interface. It's basically like you're gonna create component that you can reuse across your app. React developers are usually paid really well, and there are a bunch of courses that you can find on the internet if you want to go deeper, but you will see that most of them are actually really long, like 70, 80, sometimes 100 of hours. I believe that you need way less if you want to turn your idea into a tiny product for the internet. So here are some of the core concepts I think you should know in order to build something on the internet. There are two categories. Those on the left here are a React-only concept. And on the right, there's some advanced JavaScript concept that you will probably need in order to build your React components. Now, it would take a couple of hours if I had to go through each of those concepts, which might be a little bit too much for this YouTube video. If you really want to go deeper with me and code along, I have created the course named CodeFast, where you have all those fundamentals concepts and we go over each of them. And now in this YouTube video, I'm going to give you a quick overview of all of those concepts. First one is that everything in React is a component. If we go to one of my websites, this one here, and if we break it down into React components, this is what you would see. At the top, you would have a header component, then you would have this like a big hero component, and then you would have this smaller one, this button checkout component. That allows me as a developer to write once, and then I can put this button, for instance, at multiple places without having to rewrite it every single time. So I just wrote it once, and then it's here displayed at multiple locations. Now let's go to your code editor. I am going to remove actually a bunch of things we don't need here, that and that. I'm going to save this, and on the right, this is what you would normally see in your localhost 3000. Since we're going to write a bunch of components, a common practice is to create a new folder called components. Inside of this folder, you're going to create one file per React component. In this case here, the demo I want to show you is a counter component. So I'm going to name it counter with a capital C and then .js for JavaScript. It's important that you name your components as well as the file name in a way that is easy for you as a human to understand as well as easy for an AI, so that later on the AI can go through your code base and understand it easier. And this is a React component. It's very simple. It's just a simple JavaScript function, so function counter. Here is the name of your component, and it has to return something. That something here looks like HTML. It is not actual HTML, it is JSX. This is the notion here, JSX. It's a syntax language that we're going to use to basically return every things that we want to show to our users. In this case, I am just returning this div, which is very simple. Now I need to show this component to the user, and since one component is inside of a file, we need to export the component so we make it available to other files. So then, for instance, in this page.js, we can import the component from that file and we can display it right here. Now when I press save, you can see that I have this little counter being shown here. And since it's a reusable component, then I can show it even 3 times if I want, and I will have it 3 times right here. And so this component now is reusable. I can use it across anywhere I want in my app. Now there's another important notion in React called props. Props are like properties that we are going to give to components so they can be customizable. In the function to create a React component, there will be a parameters pass named props. This is an object where we can pass specific properties so the components can behave differently. So in these props, we're going to show the title. Now, if I go back to my page.js, what I can do is I can add title And I can give it the value of counter 1, counter 2, counter 3. And now when I press save, you'll see that I see counter 1, counter 2, counter 3. And so thanks to this prop thing, then for the same component, I can have different output, different look, different customization. Now with just those few things here, you can already create a nice landing page, just a visual landing page to present your idea. You might want to have some kind of user interaction, like what happens if someone clicks on a button. And for that, we need to introduce the notion of server and client components. So there are two types of React components. By default, all React components we create are server components. And the difference between a server and a client component is basically when is this component rendered. So in the case of a server component, if a client, someone, a visitor from the internet goes to your website, the server is going to take the React.js component, is going to compile this React.js component, which means it's going to turn this JavaScript code into HTML, and then it's going to send back to the client this HTML component. In our case, the counter.js React component is a server component because it's the default value. So whenever we navigate to localhost 3000, the little script running in our computer is turning this JavaScript code into an HTML code and sending back to the client so that me as a person, I actually see HTML here in my internet browser. Now, in some cases where you want to have user interaction, like people click on buttons and you update the components, you want to use React client components. In this case, when the client goes to your server and asks for whatever page, React is going to check the client components and is going to send them back as they are. And then when the JavaScript code returns on the client, then React is going to swap this React.js, this JavaScript code into an actual HTML. The rendering process is going to be done on the client side. Hence, it makes it a React client component. To make a React client component, all you have to do at the top of the file, you just have to write quote, quote, use client. And now since my counter is a client component, that gives me access to more React features. For instance, I have access to React hooks like use state and use effects, which are a very handy function that's going to help us perform some actions. We're going to cover that in a minute. And we also have access to the unclick listener, where we can listen for events for like when people press on buttons on our app. So now we have a client component, we can listen for clicks. Let's actually turn these components into like an actual counter. Okay, so here I have updated the code. Don't mind about those class name thing. Those are just used to style a little bit the counter. We're going to cover that in the TailwindCSS section. What we have here, first we have imported the function named useState from the React library. This is the most popular React hook, which is used to save a state, the actual state of a component. In our case, we want to save the actual counter, how many times the button has been clicked on. We're gonna write this line where we call the function useState. 0 is the default value. By default, the value of the counter will be 0. And then we have here a stateful variable named count and a setCount, which is a function that we can use to update the stateful variable. And right here, I am just displaying the value of count. And you can see for the 3 counters, we see 0. One of the big perks of using those like stateful variable is that whenever we update the count using setCount, React will re-render our page. It will show the new value of count without us developers having to do anything. All we have to do is to just call the method setCount. So here I have created 2 buttons, a minus button and a plus button. One will decrement the value of count and one will increment it. On each of those buttons, we have this event listener on click so that whenever a person clicks on the button, then it's going to trigger a function. And this function is this thing here. This will be called whenever someone clicks on the plus button or the minus button. And what this function is doing here, it's calling the setCount function, this one, that is going to update the count. And we're going to reuse the previous value of the counter, so the actual value right before the click. And we're going to say that the new value is the count value minus 1. And exactly the same for the increment counter, where we're going to say plus 1. And so now you'll see that when I press the plus button, the value of count is updated. And since it's a stateful variable, in the background, React re-renders the component and shows the actual new value. So those are some of the core and fundamental concepts of React, and you will see that you can go already pretty far just with some of those. Okay, now the next concept is NextJS. It's a React framework. It's mostly going to be used to organize your pages. So we're going to write React components, and we're going to put all of them inside of one page. And NextJS in the background is going to turn this React.js code and compile it so we can give it to people on the internet as HTML. These are the fundamentals of Next.js I think you should learn. Of course, there are a bunch of other features that they have, but those ones here will get you pretty far. So for instance, a page.js, it's a file convention. Whenever you write inside of your code page.js, Next.js is going to create a new page for you. So this right here, this entire thing is a page. Actually, if I look at the content inside of page.js, you can see that I am exporting a function with a capital letter that is returning some JSX. And what you can notice here is that a page is actually a React.js component. It's just a big React component that is going to have other components inside to be shown on the client. So Next.js is going to help you organize your pages. Now, let's say we want to have another page at /dashboard, like a private dashboard for your customers, for instance. What you can do is you can create a new folder named dashboard, the name of the actual path you want, inside of the app folder. And inside of this folder, you create a new page.js. This is a convention. It has to be named page.js. And here you can create a new React.js component, so a function that exports some JSX. And now when I go here and I press enter, I am going to go inside of this like new page. For now, it's a boring page. It doesn't do much thing, but this is how you are going to use Next.js to create a bunch of pages for your app. Another feature of Next.js is the layout.js. So here, once again, we already have one created. This is a convention as well. You have to name it layout.js, and it's basically going to be a wrapper around your pages, and all the things you do here will be applied to the underneath pages. So again, here we have a React component because everything is a React component. And what it says here is that basically we're going to wrap all the pages. So children is a keyword in React that you also should learn. And then we're gonna wrap all those pages inside of an HTML and a body tag. Actually, we do that here because we applied this guest sense variable. So this is basically like a font, the font we actually get from Google, and we want to apply the same font on every pages. And we can do that simply using layout.js. If I want to go crazy and set a background color of red inside of the layout, you can see that in my /dashboard page, the background is now red, and the background of my main page is also red. So whenever you apply something inside of a layout.js, every thing here will be applied to all the pages underneath. There are two other things that Next.js has created for us that is very handy. Those are two React components. So we have link and image. You would use the link one in order to navigate from pages to pages. So you would first import the link component from the next package, and then you would simply do link. So you would have the href attribute, and you would point to wherever you want to point. So in this case, I want to go to the dashboard, and then you can write text or anything else inside. And then you should have a nice link on your page. And if you click, I'm going directly to the dashboard. So now you might be wondering why we just don't use the HTML tag. And the reason behind is when we use this component, Next.js in the background will do some work and is going to prefetch the dashboard page so that whenever we click on this link, it is super fast to navigate to the dashboard page. So whenever you have some navigation going on inside of your app, you mostly want to use the link component. Okay, and finally, the image component here will help you display images in the right format. So I have added this little nextjs.png file inside of my app folder. Then in my dashboard component, I'm going to import this image, and I'm also going to import the image component from the next package. And I can just use it like this. You have a source attribute where in this case, I'm passing the image. Here, the image is available inside of the project. That's why I'm using this thing, but you can also pass a URL of an image here instead. Then a few parameters and then a few styling options. And then here I can see my image is displayed. You could technically use the HTML image tag. The reason we do it using Next.js is that they are going to optimize our image. So my image right here is actually pretty big. I think the file is around 1 megabyte. So what Next.js is doing using this component instead of the traditional image HTML tag, they optimize the image. Now if I go to my console and I check the image itself, you see that I have multiple source sets. In the background, Next.js is basically trying to guess how big the size of my screen is, and is going to serve the smallest possible image size. So if you can see here, the file size is only 10 kilobytes, which is like I think 10x or maybe even 100x smaller than my original file. So it's a common practice to use the image tag to help you load images faster for your users and better for SEO as well. Okay, now the missing part of the puzzle is how to style our React components. And for that, we're going to use TailwindCSS, which is a framework around CSS. You can find it in your package.json. Normally, you already have TailwindCSS installed with NextJS. TailwindCSS is a CSS framework, which is going to make our life much easier. If you were to write an entire app using only CSS, you would do lots of back and forth between your components and the style you apply to them. And trust me, it would get very boring. Instead, Tailwind has created a bunch of classes that we can apply right away inside of our components. For instance, here in the title of my counter, I already have the TextExcel class that was created by Tailwind CSS. Their class have a good naming, so it's easier for us developers to know what they're doing. So you would kind of guess that if I apply TextExcel, the text will be of like a large font. Now, if I go crazy, if I apply text for Excel, you'll see that the counter becomes really big. And just for fun, I'm gonna say TextXS, and you see that now the counter title is very small. And actually, if I hover my mouse on the actual class, I can see the CSS class that is created for us. So this TextExcel applies the CSS property font size of 20 pixels and a line height of 28 pixels. If you don't have this inside of your code editor, just go for your extension tab and search for the Tailwind CSS IntelliSense plugin, and then it will start showing you the CSS properties that are applied. And you will see Tailwind has a bunch of classes. I think they have over 1,000 classes. For instance, this one, P6, P stands for padding, and it applies 24 pixels of padding inside of the counter. If instead I would write PX6 and PY12, I would apply 24 pixels of horizontal padding. So X stands for, it's for the horizontal axis, and the Y stands for the vertical axis. And you can see here on my card, I have on the left side and on the right side, we have 24 pixels, and we have 48 pixels at the bottom and at the top. The name of the colors as well are much easier to apply. So for instance, you kind of guess that the border applied here will be gray, which is much easier than if you had to write the hex color into CSS itself. There are a bunch of classes and you don't need to learn all of them. What I recommend you is to take all the CSS classes you need, so maybe like a font size, font weight, the padding, margin, etc., and learn only the Tailwind CSS classes you need to style your page. One you're going to need quite often is the flex container, which allows me here to create 3 containers on top of each other. So I created this little like a cheat sheet. If that helps, you can take a screenshot of it. It is going to help you organize your flex container and the flex items inside, and have like a layout where you have stuff on the top left, stuff on the top right, etc. I think I forgot to mention that we are writing React component. We are not using the class attribute, we're using class name. But of course, remember, Next.js is going to compile our project and send HTML, JavaScript, and CSS to the client. So now if I go into my internet browser, I inspect the counter, I don't have class name written, I have the attribute class written here. And if I click on it, I can see all the CSS classes that Tailwind has created for us. And of course, life wouldn't be fun as a developer if we didn't have access to UI components libraries. So the one I use to create buttons, form, cards, etc. on all my app is Daisy UI. It is a collection of pre-made components that I can use inside of my app without having to style them. So this is the Daisy UI website, and for instance, if you go to their documentation, you can have access to all those buttons. So they have different states, so if you press on them, they move, different colors, they react to when you hover them with your mouse cursor. You have avatars, you have badges, etc. You want to leverage UI component libraries as much as you can, so you don't have to do everything from scratch. Now in our project, what we can do is we can install it. So we can do npm I Daisy UI. This is going to install Daisy UI inside of my project. I'm going to restart the development server, and now we should be able to access all of their classes. Oh, actually, I just forgot one thing. I have to open the Tailwind configuration file, and then here I have to include the Daisy UI plugin in order for Tailwind to know that we are using this UI library. So now, for instance, we can use Daisy UI buttons for our counter. I think this round button would look great. So I have to look for the JSX, and they told me to add btn circle. So I just add it right here inside of the button. And now I can see that I have like 2 clicky buttons on the left side and on the right side of the counter, which make my app much more stylish and easy to use. Now is time. We are going to deploy your website on the internet so that anyone in the world can see it, and we're going to get a domain name so people have an easy access to go to your website. And for that, I'm going to give you a free preview of my course CodeFast, where we're going to go over those lessons, and I'm going to guide you step by step in how to deploy your website on the internet. First, make sure you commit all your changes and push them to GitHub. You might have something different than me here. It doesn't matter. Just commit your changes. Then go to Vercel.com. Vercel is a company that will provide a server for you so that you can put your code and you can serve to anyone, anywhere on the internet. And also, Vercel has a free plan that lets us deploy our projects at no cost. I personally use Vercel for all my projects. I have no affiliation with them whatsoever. It's just very simple to deploy a project. If you do not fancy Vercel, there are some alternatives like Netlify or Render. Once you're on this page, click Start Deploying and log in with GitHub. You will enter your GitHub's credential and you will be prompted to connect your Vercel account with your GitHub account. Authorize the connection and I will see you on the other side. Okay, now you should land on a page it's a little bit similar. You're going to go here, add a new project. And we are going to look for the repository you created on GitHub. This is mine right here. I have many other for other my project. At this moment, you might have only one. Click Import. Vercel might ask you to reauthorize something. Just make sure you let Vercel connect with GitHub. And then do not change anything right here and just click Deploy. It's going to take a couple of minutes. You have something called build logs. This is the place where Vercel is going to take all your code and is going to run it on their servers. As a little hint, you can see that it's running in Washington, DC, at least for me. This is where your server is. And then you can follow along with the time and the commands that are being executed. It looks like everything is going fine. It's generating some pages for our application. And within a few seconds, maybe a few minutes, it should be done. Here we go. The project was deployed. I'm going to continue to the dashboard and I am going to get this button where I can visit my project. And this is it. The project is available on the internet. I have a URL that I can share to any friends and anyone on the planet can see my project. Just a quick breakdown here of what we have. This is vercel.app, the domain name that Vercel owns. And they give you a subdomain on their domain so that anyone can access your website. Later, we will connect our own domain, so we don't need to use the Vercel one. And if you're running into any kind of issue during the building process, you can go to the build logs. And then here you will see probably some red color. It will give you a hint of what is going on, what broke down in the deployment phase. If you have a code that is a little bit different than mine, you might run into an error or two, and it's perfectly fine. Normally, they will tell you where the error comes from and how to fix it. Just copy paste this error in Google or ChatGPT to help you. Let's break down a little bit about the process. What is actually going on? So you are working on your computer and you make changes on your code. And when you press the commit and sync button, it's going to run those commands, git commit, git push, which is going to send the new code to GitHub. Now that we've connected Vercel and GitHub, then whenever there is a change on GitHub, Vercel will be updated. So Vercel is going to run two commands. npm run build is going to check the new code and create a bundle of all the pages. And npm run start is going to start a little development server on Vercel and is going to start listening for requests from people and serve the new pages updated with the new code. Let's dive just a little bit deeper into those two commands. So on your local machine in the package.json, you have those three scripts. The one we always run is npm run dev. And the one that will run on Vercel by default is npm run build and npm run start. The npm run build, you can actually run it on your computer if you want. Just stop the development server and say npm run build. You can just follow along with this tutorial as well. You don't have to do it. The npm run build script is creating an optimized bundle of your application. And once it's done running, it's going to put all the code in the .next folder. It's a very complicated folder with stuff we'll never touch, but the code is there and it's optimized to be sent to visitors. And the npm run start command is going to start a local development server. So it's listening for HTTP request and is going to use the .next folder to give the right HTML pages. So somehow those two build and start script are a little bit similar to what the dev script is doing. The dev one is used on our local machine because it has some extra features, like if you save a file, for instance, it's going to refresh the entire page so that you can see your changes right away. But for production, it's good we create an app that's as small as possible. That's why Vercel is going to run those two scripts. You are now entering the most exciting part of the course. We're going to buy a domain name. And usually developers will buy a domain as soon as they have an ID, and they usually never push code to it. So congratulations, you already have a tiny application, and we're going to connect this with your future domain name. Also note that you don't have to buy a domain name right now, although I really recommend you to do so because it's a very important part of the entire journey. You'll need a domain name for the business side of things. You'll need a domain name to rank your pages on Google. You'll need a domain name to send links. In the course, I'll always do my best to make sure that there is an alternative where you don't need a domain, but it's a very good thing if you do so right now. To buy a domain name, I usually use Namecheap. For no specific reason, I have no affiliation with them. I just like them. There is GoDaddy that is also very popular. Since I named my app CodeFast SaaS, I will search for codefastsas.com. Hopefully it's available. I think it is. It is available and it's pretty cheap, which is nice. If your .com is not available, you can go with any other extension called TLD, top level domain. The .com here is one of the most popular, but you have many others like .org, .net, .io. There are a bunch of them. And it really doesn't matter which one you use. I own a .st domain like codefa.st, and this doesn't make any difference. If you already have a business name in mind, go ahead and purchase a domain that is related to that. If you have no clue what you're going to build in the future, what you can do now is you can purchase something that is related to your name so that you can build a little portfolio website later. For instance, I own marklu.com, and this is my portfolio of little projects. Then proceed to checkout, create your account, and I'll see you on the other side. Okay, now I assume that you have both your domain name, so congratulations. One of the things you want to do first is to enable the auto renew feature. Because you actually do not own the domain name forever, you are actually renting it for a year, and this will ensure that your credit card will be charged every year, so your domain name doesn't go away. Because in that case, you can actually lose it if someone purchases it. And if you are using another domain register than Namecheap, for instance, GoDaddy, the auto renew feature will be there for sure. It's just going to be at a different location on the user interface. And then the part we're interested in is called Advanced DNS. If you're using another register, it might be named a little bit different, like Manage DNS or Zone File. You are looking for a user interface where you see these kind of things, where you have type, host, value. We're going to use these settings here to connect people who are visiting our domain name with our applications hosted on Vercel. So now going to Vercel, I'm going to go to the settings part in my project. And on the left side, there should be a domains tab. And here you want to add your domain name and then press the button add. And you can go with one or the first or the second option. I usually choose the second one. It's just a matter of preference whether you want people to visit www.yourdomainname.com or yourdomainname.com. And then when you press add, Vercel is going to give you the instructions to connect your domain name and the project. So here they're telling me I should add a record in my DNS of type CNAME with the name www, and the value should be this. So copy that value here and go back to your DNS settings and add a new record. The new record was a CNAME record. We're going to go over that in a minute. The host or the name is www, and the value is the one you just created. Then press save change, and we're going to do the exact same thing for the second one, the root domain, the domainname.com, where this time we need to add an A type record with the name of @ and the value should be this IP address. So I'm going back to Namecheap, and I'm going to add this new record of type A. The host should be @ and the IP address should be this. Then save the changes and let's go back to Vercel. And normally within a few minutes after refreshing, they will connect successfully the domain to your Vercel project. It could take up to 24 hours for those things to connect. So if it doesn't work within the first 5 minutes, it's totally fine. If it still doesn't work after 24 hours, you want to go back here and check that you put the exact same thing here to make sure that everything is correct. Now that it is working, I can see that if I go to codefastsas.com, then I end up on my Vercel project. And then I can send this link to anyone, my friends, my family, and they will be able to see the exact same thing as me. Let's go here just to understand really quickly what's happening. When someone visits your domainname.com, it's going to go first to the DNS. The DNS is Namecheap or is GoDaddy. It's basically a big server that you can compare with a phone book if you're an old person like me, where they map domain names to IP addresses. People in general will never remember IP addresses, it'll be way too complex, so they remember something simple like a domain name, and then the DNS will do the work of mapping the domain to an IP address. And this IP address is an address of a computer on the internet, and it's magically the Vercel computer where we host our project. Vercel is going to receive the request and return the right page to the client. I went a little fast when purchasing the domain name, so let's break it down. Let's say for this example that I own domain.com. When I own domain.com, I also own any subdomain underneath. So I own www.domain.com, email.domain.com, anything I want to create .domain.com. Subdomains are pretty useful when you want to separate some things. Let's say you want to have a subdomain that is responsible to send emails, a subdomain like blog.domain.com that serves a different application that is dedicated for your blog. You'll see that it could be quite handy. And when you purchase a domain, you can edit the DNS records, which are used to map domain name requests to a specific type of data. There are many types of domain name records. We're going to study the most common ones. A records, which stands for address, are used to map a domain request to an IP address. The @ sign here is used to describe the root of your domain, so domain.com, but you could also have like a subdomain here where you could write www or email or blog and then map it to whatever IP address of your server where the code is running. Address records are the most common ones because it's super simple. Someone goes to your domain name and you redirect them to your server. CNAMEs records, which stands for canonical names, are used to create alias or subdomains. Here you would add the subdomain, so www, blog, email, whatever you want, and then you would map it to another domain name. This is quite useful if you want to redirect someone from your subdomain to your root domain, for instance. MX records. MX stands for mail exchange, are records to tell what to do when we receive an email at, let's say, mark@domain.com. And the value here should be the domain name of a mail server. It's usually a company that knows what to do with incoming emails and could either save them, forward them, reply to them. It's usually a paid service. And finally, we have the TXT records. TXT stands for text, and those are used only for display purposes. So all those records are public, meaning anyone can see them, and we typically use TXT records to show that we own a domain, to verify a domain. For instance, if you want to submit your website to Google so that they know you exist, they will probably ask you to add a TXT record with some kind of like a unique identifier just to show that you own the domain and you were able to update the value here. Alright, at this point, you already have a bunch of information and knowledge in order to deploy a website, show it to friends, you can present your ideas, you can do already a bunch of things. What I really recommend you to do is to build a little portfolio or build like a demo page for your idea and put it on the internet. Now we have built mostly static websites where people can view stuff, but they cannot do much apart from just seeing your website. This is where we have to introduce another big notion in programming called the backend. The backend, in other words, is like all the things that your users don't see. That can be like saving information into a database, that can be creating a user account, that can be calling another API like OpenAI to summarize a piece of text. It includes really a bunch of stuff that are invisible for users. And of course, we want our front end and our backend to communicate, and for that, we're gonna have to create API endpoints. An API endpoint is basically like a little door on your server so that your front end can communicate with your backend. So there are two parts. The first one is actually create an API endpoint on the server side. So these are some of the core concepts we're going to go over. And there is the front end part, the thing that will our users, our visitors will be able to play with, like touch buttons, etc. And these are some of the core JavaScript concepts that we need for our front end to communicate with our backend. Now, to understand a little bit about API endpoints and create your first API endpoint, I'm going to give you again access to a free preview of my course to guide you step by step. And right after that, we're going to go back to our counter project, and we are going to see how we can call like APIs like OpenAI, ChatGPT APIs, for instance. API here, API there, all developers are talking about API. So what is it and why do we need API anyway? The most common way to transit data on the internet is when someone is visiting a website, the server is returning an HTML page, the visitor is happy. But an HTML page is not the only way that data travels on the internet. In fact, if you go to the catapi.com/image/jd.jpg, you will get back an image of a cat. This is not an HTML page. And if you go to this YouTube video of a guy wearing the same shirt as me, and by pressing the like button, we are making a request on the internet that is sent to the YouTube API. Now that you are a developer, you'll see that internet is not just getting web pages. You can also update data, set data, get images. There are many other things we can do on the internet, and this is where the terms API come from. An API is basically a generic word to describe that a server has opened some doors for developers to perform some kind of actions. When you build software and web application, a common use case is to have an API on the server so that our front end, the HTML pages, can communicate with the backend. We're going to create an API so that people can sign up for the service, log into their account, or even create a feedback board, for instance. And each of these individual functionalities that we're going to create are called API endpoints. You can imagine an API endpoint as a door to the brain of your application. But APIs are not limited to only connection between web pages and servers. They can be also server and servers. Without realizing it, you've already called an API earlier when we created the database and you used the MongoDB package in our application. We were talking with the MongoDB Atlas API. On their servers, they have created an API endpoint that says, give me your connection string, give me a request, and I'll perform this action for you, so that two servers can communicate to each other with APIs. Theory is good, but practice is much funnier. So let's code our first API endpoint. In the old days, developers would have to create a dedicated server for their API. But luckily, with modern technologies, we can create an API right here inside of our NextJS project. The first thing we want to do is we want to add a folder called API into the app folder. That way, we make sure we separate all the rest of the code, the pages and the images and the components from the API. And inside of this API folder, we're going to create another folder called Auth. Auth is a short word for authentication, and it would kind of make sense for us as we're doing user login, logout for now. And to create your first API route, NextJS made a convention. Whatever file that is named route.js will become an API endpoint. And we're going to write export function gate. The export keyword, it just means that we can use this function outside of our project. The function keyword is here because it's a simple JavaScript function, and the get should be capitalized. And it means that when anyone makes an HTTP GET request to our API endpoint, we're going to execute the code that's inside. If you remember from the previous lessons, there are four major types of HTTP requests. There is the GET one, where usually you request information. There is the POST one, where you are adding some information to a database, for instance. There is a patch one when you want to edit, and there is the delete one yes, you get it. And then we're going to return this thing here. So let's break it down. First, the response is a global object that's available. Our project is using JavaScript, and there are some objects that are available to us developers. The response one is one of them. And it's basically the response that you send when you get an HTTP request. Because remember, to transit data on the internet, we make HTTP request with a method, the get method, for instance. So we receive a request and we answer with a response. And the response is here to help us format the data so that it can transit on the internet. If you hover it, you will see that there are a few methods on it. If you don't like what the person sent you, you can reply with an error, like your email is incorrect. You can send some data in JSON format. You can also redirect the person to a different URL. There are a bunch of methods. And in this case, I'm just using the JSON method. So I'm going to send back some data. And the data is this JavaScript object that is going to be formatted in JSON format. Maybe we can give it a try. So let's go to our internet browser. Maybe we open the developer console so we understand what is going on here. Go to the network tab to see that how the data will be transiting. And type localhost 3000. And then since we're putting everything inside of the API folder, you have to write /API / the other folder we created for user authentication, so /auth. And when you press enter, you'll see that there are a few things happening. First, I'm not getting an HTML page back, I'm getting some data. And now if we look at what is going on here, we see that we have made a request. And when we click on it, you'll see some interesting information. So we've made a request. The URL is the one we just type in the internet browser. The method is get, because as a person, whenever you type something in your internet browser, it will make a get request. All the other method, post, patch, delete are for developers. Since you're going to spend most of your time creating API endpoints and making communication between frontend and backend, let's study those concepts a little deeper, and let's also see how we can call another API like ChatGPT. And let's take for that an example. Let's say that every time as a person I press one of those buttons, I want to send this information and save it into a database. For that, I will need to have an API endpoint that is receiving some information, whether or not the user press the button plus or the button minus, and save this information in a database. Of course, we would need first an API endpoint. This is what it looks like. I have created another route.js file inside of /API/counter. Here we're using a post function because we're going to send some information along with the API request. We're going to say the user pressed the plus button or the minus button, and we need to know this information specifically. And then we're going to use a try-catch block. This is very important. This is very common in JavaScript because sometimes things will go wrong. We programmers make mistakes, and we want to have a way to gracefully handle those errors. We don't want our function to crash. For instance, if I write some code that is not JavaScript, when I try to execute this function, it's going to crash. And in the front-end part, when people click buttons, we don't want to show them the logs and these weird errors. We want to tell them like, oops, something went wrong. So what the try-catch block does is going to try to run all your code inside, and if there is an error, then it's going to catch this error into the catch block. And then you can safely return some information to the user and say something like, oops, sorry, try again. Okay, now in this catch block, first, we're going to create a new variable called body. And for that, we're going to use the JSON method on the request object. Since we're making HTTP request and response, now we're receiving the request from the frontend. The .json is a method that is going to turn the JSON format, which is a typical format for how data transit on the internet. We're going to use that to parse the data and make it into a JavaScript object so we can use it inside our API endpoint. And this method is asynchronous, so we're going to have to use the await keyword, which is why we also declare the function as an async function. Those async await keyword are very important, especially when you deal with API endpoint, because now between the frontend and the backend, we can have like a frontend where the user is in New Zealand and my backend could be in the United States. And so the data has to transit from New Zealand to the United States and come back. That's why we need these async await features to execute code where we don't know how long it's going to take. Okay, the next line is called JavaScript object destructuring. So this body object has information that we send from the front end. We're going to destructure this object and extract those two properties. So this refers to HTTP parameters. We're sending parameters along with our HTTP request. For instance, we're going to say like, this is the counter number 2, or this is counter number 3, and this is the action, increment or decrement. Those are parameters we pass from the front end to our backend. Here, in this case, I am just going to console log something. So whenever I press on this button here, you'll see that in my console log, I see counter 1 incremented. And if I downgrade the counter 3, I will have another log that says counter 3 decrement. Of course, here, this is not the most interesting thing you can do with the backend, but you could do a bunch of other things here. For instance, we could have saved this information in a database. We're going to cover database a little bit later. You can compute some data, like do some math or advanced stuff, and you can even call another API like OpenAI. So for instance, now if I go to OpenAI API platform, this is made for developers. You would typically log in or sign up to create an account. They'll give you a little API key. We're going to cover that later as well. And then very simply, you can just call OpenAI, for instance, to summarize a text that was given by a user, or to fix typo. You can generate photos out of text. You can do it using their library. So there are two parts. First, you need to install this OpenAI package, and then you just have to run this code right here. This is not going to work, but just to show you, you would just typically run the code, like copy paste the code they give you right here. I would need to import the package, etc. But you can just run the code just like this right here. And then your API endpoint is going to call another API endpoint that was created by OpenAI that is going to return you back some data that you can send back then to your frontend. And you can make a bunch of multiple API endpoints calls if you want. You can go as crazy as you want. This is just as simple as this. Okay, and now finally, we need to return information information because remember, HTTP is made of like a request and a response. And since this is the backend, we need to return a response. So we use the next response object that is given from next server. So it's a little helper for us to send back information to the front end. And we said that we want to format the data we're sending back into a JSON format. And here we are passing an object with some data. In this case, I'm passing success true. And something interesting too, here in the catch block, you see we also have the same object of the data we want to pass back to the front end. And we also specify something else where we say we give an object and we say status 500. Because remember, when you make HTTP requests across the internet, there are codes like status code to say whether or not the request was successful. By default, it is 200. 200 means everything went well. This is by default, so this is what we're sending back here. In this case, something went wrong, so we want to tell the front end that something went really wrong. That's why we're sending the status 500. Okay, so this is for the API part. Now for the front end, we want to tie the click of this button to the call to the API. So this is what I have done. First, I have created a new stateful variable called isLoading. This is going to be used in order to show a loading state to the user. So what I want to do is when the person clicks on the button, I want to put everything on hold, like, wait, we're loading information, we're sending this information to the backend, wait a minute. And then when the information comes back to the front end, then we want to say, okay, it went well, you can call it again. I am using it inside of the two buttons we have created, this disabled attribute. If it's true, then the onClick event listener will not be triggered. So if isLoading is true, this button will do nothing. We could use this to prevent people from double clicking on buttons, for instance. So I also have updated the onClick event listener. I am not going to run code inside right away. I'm going to call a function that I created called handle counter action. And I am passing parameters, like one parameter, so that the function knows if it's a plus or a minus button. Here I pass decrement, and here I pass increment. So this function here is this one right here. It is, of course, an asynchronous function because we're going to call the backend. So we don't know how long that's going to take. So we have to make it asynchronous in order to be able to use the await keyword. It receives the parameter action, so we know if it's a decrement or an increment function. And the first thing we want to do is to set the loading state to true so that the user cannot double click on the button. Then we have a nice try catch block. And there is another part in the try catch block called finally, which is going to execute after the try or the catch block is done. So no matter what, this will be executed after try and catch. And because here, no matter if we got an error or not, we want to set the loading state back to false so that the people can press the button again. In the catch block, we just log the error. We could have a little pop-up that says like, oh, something went wrong or something. It's not a big deal right here. And then in the try block, this is where we make the call to our API endpoint. On the front-end side, to make an HTTP request, you're going to use the fetch method. This function gets two parameters. The first one is the API you want to target. So in our case, we created /API/counter. That's why it is here. Maybe you want to call an API that is not yours or an API that is a different location. You can just also add the actual domain here to call basically any API you want. And the second parameter are all the options we're passing. So this is a big object. In the first part, we have the method, which is very important. So here it's a post method. So we're making a post HTTP request, which is exactly the same post as we have here. Then we have headers. Headers are like a kind of like metadata that are passed along with HTTP request. Here we're saying that the information will be of type application.json. This is the format of the data we're sending. That's why here we have to parse those JSON data and turn it into a JavaScript object. And we have the most interesting part, which is the body. The body is usually where we pass some information to the backend. Since we're sending JSON format, we have to use JSON.stringify method in order to turn our object into a valid JSON format. And here I want to pass two things. I want to pass the action, so increment or decrement, the little parameter here for this function, which is going to be of value decrement or increment. And I also want to pass the counter ID, which is a unique identifier for this counter. So counter 1, counter 2, counter 3, so that on my backend, I know which counter sent me this information. And then when we call this function, it's going to return a response. So since we're going to wait for the response from the backend, right after, we will have access to the response. If it is not okay, this is going to invert. So if response is not okay, then we're going to throw an error. So this is automatically going to tell JavaScript to enter the catch block, and here we're just gonna log the error. And then of course, if the response is okay, so the API answered well, so everything went well, then we're going to update the state, the counter state, and we're going to increment or decrement the state of the counter. And now, just like this, each of those counter is going to make an API endpoint. So it's going to call this API endpoint. For now, we're just logging the data inside of the console. But you have basically done what developers do most of the time. You create a nice front end for you people to interact with. You create an API endpoint where you handle those interactions, and you make them communicate with each other. Okay, now we are entering the world of databases. No matter what you are building on the internet, chances are you will need a database at some point. We can do very simple things using database, for instance, like saving user after they log in so that we can retrieve whether or not they're actually like paying users of our service. Or you can do more advanced stuff like saving logs and information so later you can see what happens in your app. A database is like a big bucket where you can put lots of information and retrieve this information really fast. Usually when you build like complex and advanced software, you want to think about how the data works first. This is something called the MVC, the model view controller. The model is the data, the view is what people see, and the controller is how the view updates the data. So whenever you have a software idea in mind, you always want to think data first. So for instance, you want to build a social network like Facebook. You have to think like, okay, we need users in a database. Each user has a name, an email, etc. Then we have a list of posts, like things that people can write. Each post has a user associated with it, has a published date, has a text, a description, an image, etc. And then on top of these data, you want to build your API endpoints to update the data. And then you want to create the front-end part to call those API endpoints to update the data. This is the typical workflow of a proper engineer. To be honest, what I love to do is to just create buttons and stuff and then update the data later, but I might get canceled for saying this. So anyway, let's study this database. I want you to get started ASAP, so I am going to give you again access to a free preview of my course. We're going to cover how databases work and how do we connect it with our API, for instance. We're going to talk about Atlas, which is a service that lets you deploy a database because we need to actually have a server on the internet that we can store a bunch of data, and Atlas is the one we're going to be using. And of course, I forgot to mention, but we are going to use the MongoDB type of database. I'm going to explain why and what is the difference between this database and other types of databases. We're going to install a little software called MongoDB Compass to help us visualize our data right here on our machine. And finally, we're going to create a little helper function so that whenever we are inside of one of our API endpoints, we can easily connect to our database to easily write or retrieve information. Before we start writing any lines of code, let's understand the overall architecture of a database. How do we call a database? So your clients, a user, a visitor will always make requests to your web server. The web server right now is the little program running on your computer. Later, it will be running somewhere in the cloud so that anyone can access your app. At the moment, we don't do anything complicated. The web server is basically compiling your React components, creating an HTML page, and sending back to the client. But at some point, we want to do some more advanced operations, like the user maybe is asking for the dashboard page where they have access to some of their private information, which in this case, we have to access the database. The database is a place where it's another server, and it's a place where you only store data. You pretty much don't do anything else. It has an API key called a connection string that lets anyone with a key do anything on the database. So we never want to make a direct connection from the client to the database. We want to do that connection from our web server to the actual database. So for instance, if the user is asking for the dashboard page with his private information, our app will process this information, create all the React components with some empty data, and then it's going to ask the database, we need this information about that user, get those information, put that information in the HTML page and send it back to the client. This is pretty much how any database on the internet works. There are two types of databases, SQL for structured query language and NoSQL for non-structured query language. SQL databases are databases that are more, as the name suggests, structured, where it's a little bit like a spreadsheet where you have columns and headers where each data is labeled. So every user has a name, every user has an age and things like that. We're going to go with the NoSQL, where it's more flexible, where the data is stored as a little bit like JavaScript objects. But the big difference is that we don't necessarily need to have a name, an age, and a hobby for each users. We can have a user with hobbies, we can have a users with no hobbies, and another value as a job, for instance. It's much more flexible. And for this lesson, we're going to choose MongoDB as our database, which is a NoSQL database. It's one of the most popular NoSQL database in the world, and you will see it's very simple. Now, just a little bit of wording with MongoDB. What we call a document is a little piece of data. For instance, when we save a user in our database, we could create a new document. It's written in JSON format that we've studied before. So you would have opening curly braces and closing curly braces. And then you would have a set of key value. The value can have different types. As we've studied before, you can have a string, you can have a number, you can have a Boolean, you can even have an array or an object. When we have multiple documents with similar values, it's called a collection. For instance, in our database, we'll have a collection of users. And you can create a collection for pretty much anything you want. You can create a collection for, let's say you have a marketplace with jobs available. You can create a collection for jobs. You have access to the Twitter database. There might be a collection for a list of tweets. It goes on and on. And then all the collections combined together form our database. Normally, for any business you create, you would have one database. If you create a new business, you would have a new database. And from time to time, if you want to test something on one of your apps, you can create two databases for one of your apps. So if you break the test database, the production database is still okay. For our database, we're going to go with the MongoDB Atlas to host the database. And they have a free plan, so we're going to get advantage of that. You're going to go on the website link and click try for free. Then create an account and I'll see you on the other side. Then you will end up on this page. Just fill the information with whatever feels right. It doesn't really matter. And then we're going to start creating our first database. You want to go with the M0 type of database. It is free. You want to disable the preload sample dataset. We want an empty database and pick a region of somewhere in North America. It is where the actual database will be. And it's important to choose something in the North America because it's likely that it is where our web server, the brain of our app, will be also hosted. So we want to minimize the distance between the two. And then you can just create a deployment and you might have to face a little CAPTCHA. Okay, you will arrive on this page and to connect to your database, also called a cluster, you'll need to set up a username and a password. Then you can just create a database user. So these users that I just created will have access to the database and you can say choose a connection method. You can choose Compass for now and we're just going to do this. You're just going to copy that little complicated URL that we have here, put it somewhere in a notepad or something. We're going to need it later. And then you can click done and you should be good to go. We need to set up a little thing. So on the left side, go to the networks access setting. And then add an IP address and you will say allow access from anywhere and then confirm. The fact that we allow any IP from the internet to access our database does not mean that they can do anything. They still need to have credentials to access the database. The IP verification thing is just an extra layer of security that we need to remove because if you go to a coffee shop, for instance, your IP will change and you will need to every time update your IP in the database. And also later, when we're going to deploy our application to production, we will not be the one accessing the database. It will be our web server that will access the database. And we don't necessarily know the IP of the web server. So it's much easier to allow any IP to access the database and just verify using the credentials. Okay, then you can go back to the database and we're going to explore a little bit this part. This thing called cluster 0 is your actual cluster. It's a physical space somewhere in Oregon in the US. Where you own a little part of a server and your database is hosted. So let's browse the collection, see what we have in there. And normally your database should be completely empty. So what I'm going to do is I'm going to add my own data. I'm just doing it to show you. You don't have to follow along with that. The database name, we're going to call it, let's say, production. And I can create a collection in this database. And let's say we're going to create a collection called jobs. And here we go. We are in the database called production. We are in the collection of jobs. We can create multiple collections, and we can also insert document in each of those collections. I'm going to insert a job of the title entrepreneur in the database. And here we go. We just created our first document in our database. You'll notice that we have this -id equal a long string of characters. This is something that is proper to MongoDB. That's how they identify unique documents. That's what makes them super fast to search across millions of documents. You don't really want to touch any of this. It's added by default, and we're going to use it later to retrieve and edit documents. Okay, now we want to install something called Compass, MongoDB Compass. So go to the link below and click download now. Here you will have to choose your type of platforms. By default, I think it knows which one you're using, then click download. Follow the instruction to install the application, and once you're done, open it. And you will end up in a page that looks like this one. We want to connect to our database. For that, you're going to pass the string we copied previously. This thing here is basically the key, the API key to your database. Anyone with this can do anything on your database. That's why it has to remain private. In MongoDB, it's called a connection string. It always has this structure, this little piece of text here, then the username, column, and then the password @ and then the URL to your database. If you ever forget this link, just go back to Mongo Cloud, click connect, and then when you click Compass, it will tell you the actual connection string. And if you ever forget your password, then in this case, you would have to recreate a new user. So for that, you will go to database access, and then you would edit the actual user. So my username is Marc Louvion. You would edit the password. You cannot change it, so you have to create a new one. You can auto-generate one, and then you would have a new password for the same username. And you would copy paste those details right here. Okay, now we can connect. So now we're connected on the database. You'll see on the left, we have different types of databases. Admin, config, and local are stuff that are added by default. You don't want to touch any of those. And we're going to go to the production one. Since I already created the collection jobs, it's displayed here. If you want to have fun, you can create one just to play around. And I'm going to do this with you. I'm going to say maybe users and then create collections. I'm going to add a user. I'm going to add those information to the user. Since it's using JSON format, you always want to write the key with quotes at the beginning and at the end. And then you can write either text or numbers or booleans. I'm going to click insert, and now I have a new collection of users with one document. And then I can do a bunch of things. If I want to retrieve a user, I will have to pass a query. So I would have to write curly braces, and then the name of the value I want to filter. So is entrepreneur, column, and then true. And then when I press enter, it's only going to return documents where the key is entrepreneur is true. And you can do a bunch of other really cool stuff. Like, for instance, I want to find users where the age is greater or equal to 30. So I can use this little syntax here and press enter, and it's going to return those users. If instead I write 40, it's going to return no other users because I am not 40 yet. And by double clicking on any value, you can edit their value. And you can also check the type of data that are stored in a database. So the email is a string, the age is int 32, it's an integer, so kind of like a number, a boolean, etc., etc. And recently, with the new boom of AI, you have this generate query feature. You might have to log in to your account again so that it works. It's a quick overview here, but basically you can speak in natural language, and it's supposed to give you back the type of query you're supposed to run. So let's try with this, find users where age is lower than 40, and it generated this little query here. And if I press find, it's going to query those users. As we build our application, we're going to go a little bit deeper about how to retrieve and how to edit data in the database. For now, you have a rough overview and you can visualize all the data with MongoDB Compass. Okay, so now that we know how to edit our database with our hands and our eyes, let's do this with code. For that, we'll need to add our connection string somewhere in our application. And because it's a very sensitive data, we want to do it in something called environment variable. So the first thing you want to do at the root of your project, you want to create a .env.local, and I'm going to put it in the root. There we go. And here you want to first name the variable. I'm going to call this Mongo URI. You can call it the way you want, just make sure it's capital letters and there is no space. If you want to add a space, you need to add a dash, then equal, and then the value that we get previously from MongoDB. We can save the file and try to understand a little bit what is going on here. First, you'll notice that inside of the git ignore file, there is this thing that says .environments.local are basically ignored by Git, which means that anything you put in here will never be pushed to Git. So it's a safe place to put everything that is secure in your app. So the connection string, your Stripe API key to process payments, your API key to send emails. We'll study that later, but this is the place where you're going to put every sensitive information. You'll also notice that we're not writing JavaScript, we're not importing anything, not exporting anything. It's a very different structure than we've studied before. It's something very specific to Node.js. Okay, to understand how to get this value in the code so we can query our database, I'm going to log the value of it, process.env. The name of your variable. And if you do this and look at the console, you will see that I actually get the value right here. It's because we have this script running on the computer, npm run dev, and it's basically looking at any environment file, so a file that starts with .env, env, and then every variable that it finds there is going to add it inside of the process.environment object. And so if you want to call it in the code, you would have to do process.env. The name of the variable. Okay, and just as a security thing, here we are doing this command inside of a React server component. So this is going to be logged in the side of the server and not available on the client. But if you reference the variable somewhere in the code and you put it in here, you'll see that we can actually see the variable. The fact that this variable is inside of this .environment file doesn't mean it's invisible to users. It just means that it's not going to be sent on GitHub. And so it's staying on your local machine. I guess I'm going to delete that part because this is pretty dangerous to do. And let's recap really quick. So this .environment file is the place where you put every sensitive information you have in your app. There are two main advantages. The first one is that the file is staying on your local machine. It's not going to be sent to GitHub. And the second is that we can have different values based on the environment our application is running. Let me show you what I mean by this. Here we are working on our computer. We are building new features. We're testing things. So we want to make sure we work on a separate database as the one that will be used by our customers. So this connection string here is going to connect to the cluster. And if we had slash and then a name, whatever name you want after, I usually call mine dev. And by doing this, we're going to connect specifically on the dev database on the cluster. And in production, where our app is running on Vercel, instead of having dev, we can just say prod. And so that we connect to two different databases with the exact same variable name. So for now, I'm going to name this one dev. You can call it development. You can call it the way you want. And I'm going to use that thing here. I'm going to go to my project on Vercel. In the settings part, there is something called environment variable. And this is the equivalent of your environment file on your local machine. But this one is hosted on Vercel. And here is where you would add your environment variable. The key is what's before the equal sign. And the value is what is after. So you can copy paste the value, and instead of having the slash dev, we're going to say slash prod. And then when you save the project, now this variable will be available inside of your project hosted on Vercel. And so now when we are working on our computer, this function that will connect to the database is going to use the MongoDB URI we have in the environment.local because we are on our computer. And when it's going to be deployed in production on Vercel, it's going to use the values that we just set up in Vercel so that we can keep the exact same code and have two different values for the same variable. And you will see that it's common for developers to work on one database when you are coding and to work on another database for the production values. A quick note on environment variables. You might have heard in the past API keys. What are API keys? Usually an API key is like a unique identifier so that you as a developer can identify yourself for the service you're using. For instance, let's say you want to use the ChatGPT like OpenAI API. When you sign up, they will give you an API key, and you will use that as a developer when you make requests to the OpenAI API. Those are extremely private. You always want to keep it for you. And the environment variable file is usually a good place to put all of your API keys. Okay, now we need to connect to our database in the code. For that, we'll need a little package called MongoDB. So just pop up your terminal and stop the current process. You can press Ctrl+C or Command+C and run npm e short for installed MongoDB. Press enter. And when the packaging is installed, let's restart the development server. So npm run dev, and we're good to go. Now we need to customize the bridge to pass, for instance, our connection string. So we'll customize a function so we can reuse that function everywhere in the code, so we can update our database anytime. It's a good thing to separate different type of functions in your code. So what we're going to do, we're going to create a new folder inside of the root directory called libs, short for library. Some people call it utilities. You can call it the way you want. I just like the word libs. And then we're going to create a mongo.js file. This will be the file responsible to connect with our database. And instead of writing some very boring code, let's use the code base I created for you. Just use the link below. You will end up on this page. You can just copy and paste the code in MongoJS. Okay, so the reason we're copy pasting this code instead of writing it ourselves is because it's very advanced, because it's very boring, and also because you will never touch this code. It's only specific to this project. Once we've created this, we'll never touch it again. Instead, I'm going to break down a few pieces for you. So first, at the top, we import the MongoDB client, so the bridge to MongoDB from the package we just installed. Then we have this if condition. So the process.environment is that things that let us access environment variable on our computer. The Mongo URI is the one that we have in the environment.local right here. And then when we try to evaluate if and then a variable is going to return true if the variable exists, it's going to return false if it doesn't exist. And the exclamation mark is going to reverse that value. So if this does not exist, if we did not add the value somewhere in our project, then this is going to return false. And we're going to reverse it with the exclamation mark, which means this becomes true. And then we enter this line, and then we're going to throw an error. We're going to go over that in the next part of the course, but basically this is going to make the code crash, so that if you forget to add this to your project, the code, the app here will show you a big error message. Then we do const URI equal the name of the variable. So we're just reassigning the value of this MongoDB URI inside of a shorter variable, the name is just a little bit more friendly. Then we have another variable, which is a JavaScript object with some options. This is just how do we connect to the database. This is some like really advanced stuff. And then we create those two variables with the let keyword. The let keyword just means that later in this file, we'll probably update the variable, give it different values. It's not a constant. And then we have a big if-else statement. The if-else statement is going to check if that is true. The process.environment is what we've talked about earlier. The node-env is a very popular environment variable. It's been given by default when we run the project with NextJS. It's going to set these to the actual environment. And the environment, remember, it could be either development on your computer or production on the web machine, on the web server somewhere on the internet. So what this line does is basically is checking if we are running the code on your computer or on the online server. And the reason we do that is because on our computer, it's a little bit different how things are handled. As you're editing code and you save and it's refreshed the entire code, it's a bit different from the server where instead we're just going to deploy the code once and it's going to be running forever. This is very advanced, but what it says is basically create a connection with a database, and if we save the file and then we refresh everything, keep the connection open instead of killing the connection and reopening one. It's just a matter of performance. Again, this is very advanced. You really don't want to get into this. This is not important. The only important line here is this one, where we have the client, the variable we declared previously,
and equal to new MongoDB client. The MongoDB client is what we import from MongoDB at the top. This is the driver that let us connect, and we give it two things. We give it the URI, which is this thing. So basically we give it the connection string, the keys to our database, and we give it an object of options with a few parameters, which in our case, it doesn't really matter. So this thing is basically a bridge to let us connect to our database using JavaScript. And that's why we have the line here, client.connect. And then we have this line, export default client promise. And so this variable here is equal to client.connect. So we are exporting a little JavaScript object that is connecting to the database. So now the thing that matters is how do we use it to connect to the database in our code. You can save the file and close it because we'll never touch it again. And then in our page.js, this is just to show you, this is not going to work right now, but this is just to show you a glimpse. It's as simple as this. First, we need to import the client promise, that object we just created that has the keys to our database. We import it from the libs folder inside of the MongoJS file. And then we say something like .db to say we want to connect to the database, and then .connection for the connection we want to check. And then we can have something like .find with some parameters to do exactly the same things we were doing before. Alrighto, so having a database is nice, but if we could actually use the database, it's even better. And for that, we're going to authenticate user. So whenever we talk about login, sign in, sign up, sign out, log out, whatever, this is what roughly authenticating users mean. So after this section, users will be able to create an account. We're going to save this user information like name, emails, inside of our database, and then we will be able to check if the person is actually a user of our application to let some people do some actions like access their private dashboard, or some people not access the dashboard because they have not yet created an account. User authentication is something that is extremely popular on the internet. So there are already a bunch of developers who've built open source projects that are working really well. And for that, we're going to use one called Auth.js. If you search Auth.js on the internet, you will find this website. You can click Get Started and follow the tutorial for whatever framework you're using. In our case, we're using NextJS. So first you need to install NextAuth at beta. And then you need to run this little command. It's basically going to give you a little token, like a unique identifier that we're going to use later to hash some information, to encrypt our information. It's not a big deal, you'll see. And then it'll tell you a few things you need to do. If you want to follow along with me and make sure you have all the steps completed, in your /API folder, you should have created an auth folder, and then you should have created this like a little bit complex next auth folder, and inside you have a route.js, and you should have this code inside. This means Auth.js is going to create a set of API endpoints for you so that you can use that to authenticate users. You should also have add your unique secret key that you generated earlier in the environment.local. And you should have at the root of your project an auth.js file. This is basically like the control center of Auth.js. Here you have a list of all your providers. For now, it should be empty. The providers, we're going to cover that later, is basically how our users are going to log into our app. So that could be using email like magic links or email and password, or they can be using social providers like Google, Facebook, GitHub. And then we should have an adapter. An adapter is where we are going to save the user information. In this case, we're using the MongoDB adapter because we're going to save the user information inside of our database. All right, now your project is set up. It's important to understand roughly how user authentication work on the internet. It's pretty much the same thing, whatever app you're using. So for that, let me show you a quick video of how everything works. So when our client visitors of our website are going to the login page of our site, our server is going to give them back a signin.html page. This page will have several options to log in, email, Facebook, Google, anything we'll set up. For now, it's empty because we haven't configured anything. In Auth.js, the type of login we choose is called a provider. So we can have a provider for Google, we can have a provider for Facebook, for instance. On this page, the user can click on a type of login they want or enter their emails and password, for instance. This is going to make a post request to our /API/auth/signin endpoint. And it's going to pass some parameters. So if they sign up with an email, it's going to send that email. If they are trying to sign up with Google, it's going to say type Google. And our server is going to receive that request and going to process it. If the user picked a social login, for instance, login with Facebook, then our server is going to communicate with Facebook to make sure that the user actually exists. And then our server is going to communicate with our database, so MongoDB. First is going to check if the person actually exists. And for that, we're going to use emails. So wherever a user sign up with, we need an email. So if it's email and password, we have the email. If it's a magic link where people receive an email and then they click a login link to be logged on the app, then we also have the email. And if the person uses a social provider like Google or Facebook, both of those services will give us the person email. So that in our database, Auth.js can check if the person exists. If the person doesn't exist, then Auth.js is going to create a new document inside of our database, so we store this information. And then Auth.js is going to create a little session for the user. The session is just another document that we'll store in our database. It's a very simple document that has a unique token, so a unique identifier so that we can easily retrieve the user. It also has an expiry date, which is usually 30 days. That's why sometimes when you log into a service, after 30 days, they ask you to log in again. And we'll use this session in order to verify that the user actually has access. So our server is going to send back this session to our client, the visitor, and he's going to put the session inside of a cookie. We're going to study cookies in the next lesson. The purpose of putting the session token inside of the cookies is that first, it's persistent. So if the user closed the tab and open a new tab to log into our app, the cookies is still there. And the cookie will be sent to every request the person makes to our server so that we can easily identify them. And the user will be redirected usually to a dashboard page or an app page. And after this process, every time the user will make a request to our server, whether to get a new page or to call an API endpoint, the cookie will automatically be sent so that our server will receive the cookie and it can easily check if the cookie that contains the session token is actually in the database and it's not expired. We talked about cookies. What are cookies? They are a small piece of data that are sent by web servers, like your API, for instance, to an internet browser. And then your internet browser is going to store this data somewhere on your computer or on your phone. Cookies are used everywhere in the internet. They're used for things like tracking analytics. They're used for user preference. Sometimes you see like a modal on the page and you say, I don't want to see this anymore. And then it's going to set a cookie that says the user doesn't want to see this anymore, so never show it again. In our case, we're using cookies in order to store the session token data so that we know whether the user has access to our application or not. Let me show you this example. This is a website that I built that is also using Auth.js. If you want to see your cookie, you can just open the developer console and go to the application tab. And under the cookie, you will normally see the domain name of your site. And if you click it, you will see all the cookies that are being stored by this website. And if I click on the secure Auth.js session token, you will see that the value is a long sequence of characters. So that now every time I make a request on this site, whether I navigate to a new page or ask an API endpoint, I'm also sending this little piece of data to the Insighto website. And on the backend, when the Insighto receive the request from the person, they also receive the cookie value and they can decide anything they want. They can check if the cookie exists, if they can check if the cookie is not expired, and they can perform some actions like if the cookie is expired, ask the user to log in again. If the cookie doesn't exist, then we have the user to sign up. There are a bunch of actions that we'll cover later. Okay, now let's be practical and talk about some use cases of authentication inside of our app. Things like signing out, signing up, protected pages, private APIs, etc. Okay, so this is one of my NextJS projects, not the one I showed you earlier, but it works exactly the same way. I have the same system for all of my apps. So here, when I navigate to my domain name or localhost/API/auth/sign-in, users will end up on this page where they will have multiple options to sign in to my applications. This is done automatically for me by Auth.js. I have nothing to do besides setting up the provider's information. So here I have created a provider for Google. I have created a provider for email. We're going to do that later. This is what you set up here in this providers array in Auth.js file. They have tutorials to help you set up any kinds of providers you want. So you want to check out their documentation. Once they sign up or sign in here, this information, the information they give me here will be saved in the database. I will get at least their emails. And if they sign up with Google, I'll also get their names and the profile picture they use for their Google accounts. So for instance, here, if I add my email and I sign up with, email, then because I am using the MongoDB adapter from Auth.js, with just this line of code, in my database, I am going to see the user mark@gmail.com created. It's going to add a unique identifier field. It's also going to check if I verify my email. If I click the link inside of my email, we're going to cover that later. So I have this information saved in my database. Then what I do, I redirect people after they successfully sign up to a /dashboard page. This is a private and protected page only for people who sign up. And the code is actually very simple. What you see here on the screen on the right side is basically just this like little JSX code right here. And no matter which user is going to my app, it is the exact same code. It's basically like a template that I fill with the data that was generated by the user. So this is the page.js file you see here. So this is the typical NextJS file. I export this React component. I return some JSX. And here, there is a function that I created. So get user, this function right here that is executed. So whenever someone go to my /dashboard page, this function is executed. And this function first calls the auth function that is created by Auth.js. With this single line of code, what Auth.js is going to do in the background is going to check if the person has the right cookies. So if the person successfully signed up to my app, and if that's the case, it's going to create a little session object with some information. But if the session does not exist, then the person has never actually created an account for my application, then they are going to be redirected to the homepage of my website. So for instance, now if I open an incognito tab where I have no cookies, it's like I am a new user. And if I go to the /dashboard, press enter, and boom, I am redirected to the homepage of my site. And with just those 3 lines of code, I am able to either show information to the right people who sign up to my service or don't show anything at all. And because this is a React server component, this is a safe place to do all the checkup, verify that the user is authenticated, so that people who are not will never actually see the content inside. Okay, now let's assume the person has created an account, so they are authenticated, they have an actual session object. Auth.js is going to populate the session object with some information. So if I go to session.user.id, this is the exact same thing as this ID here inside of my database. And that way, I can simply retrieve the user from my database using the session of the user, the actual authentication state of the user, and I can find the right information about the user. In this case, I find the user boards, those little cards here, so that anyone who goes to my app who has already signed up will see different information because everyone will have a different session user ID. And so I will retrieve only the information about the actual user who is now browsing my site. And I'm going to populate the content, the visual part of my app, with what I retrieve from the database that I got from the unique user session ID. This is how you make a page private in your application. Now let's say that I want to protect an API endpoint, like let's say this post function inside of /API/board, then I would do the exact same thing. I would retrieve the session, and if the session does not exist, then I will just return an error, like an HTTP response with a status code of 401. And that's pretty much how the entire authentication system works, how you make protect pages and private APIs endpoint for your users, how you create one page that can display different kinds of information based on the actual users who signed up, and how you reject people from your app if you don't want them to visualize or see some information.
Alrighto, now it is very likely that after authenticating users, you will need to send emails. So there are 2 types of emails in the world, transactional and marketing emails. The marketing emails is the one usually you don't like to receive as a person. They are companies who broadcast one message to thousands of users, like a discount for a product or a Black Friday deal. And the ones we are interested in as developers are the transactional emails, so we can send magic links when people want to log into our service. For that, I'm going to leave you with a little preview of my CodeFast course where we're going to select a provider, a service to send those emails, and how to set up your DNS records in order for your domain to be able to send those emails.
There are many providers out there. There is Mailgun, which is very famous, and there is Resend, which is fairly new, but it's very friendly, and they have a free plan. So we're going to go with this one, click the button Get Started, and create an account. Once you signed up, you will go to the domain part and click Add a Domain. Here you will enter your domain name, and we're going to send email from a subdomain. So I'm going to write something like resend.codefastsas.com. It's important to use a subdomain because if someone managed to hack your system and send thousands of emails to people who don't even exist with your root domain, it might damage your domain reputation. So instead, we're going to use a subdomain so that if something goes wrong, it's just the subdomain reputation that is being impacted. You can say whatever. I usually use the name of the service I'm using. You can say email, you can say mail, you can just say e. This is totally up to you. And then keep North Virginia for the location and then add the domain. Resend is going to send emails on our behalf, so we need to verify that we own this actual domain. So below there is a list of all the DNS records we need to add. So first there's an MX record with send.your subdomain with this value. You can copy those and go back to your Namecheap account or whatever you use like GoDaddy for your domain name. And then in the DNS panel that we've seen earlier, the Advanced DNS tab, you will be able to add those records. In Namecheap, there is no option for MX record here. It's just a little bit below in that category. In the mail settings, instead of email forwarding, you can go and choose custom MX. And then you can add your own custom MX records. So then I add exactly what they asked me, the host, the value, and the priority of 10, and I can save the changes. Then I can go back to resend and do the exact same thing for all the records. So send.resend as a text record with this value. So I can go back here and find the txt records and I can save this one. And I'll do again for this other one right here, add a new record, txt, and press save. And the final one, the dmarc record, which is another txt records. And so I'm going to go here, txt, and press save. And the reason we're using those text records, which are commonly known in the email world as DKIM, SPF, and DMARC records, is to tell email providers like Gmail that we are legit, so that our emails don't end up in spam. Okay, so now that we've added all the records, we can verify the DNS records. It could take a while. It could take sometimes up to a few hours. DNS records are pretty slow to update. Just make sure after an hour or two, if it's still not verified, to make sure that you've entered the exact same values as they show here. Since my domain is verified, now I'm going to go to the API keys section and I'm going to create an API key. You would normally call it the name of your project. So for mine, it will be CodeFast SaaS. And then for the access, select sending access and then the domain we just added. And then click add and copy that key. Then go back to the code editor and the file.env.local, add a little key called resend-key or whatever you want, but just make sure you use the word resend so you remember what it is. And then equal, and then add the key right here. This little sequence of character is called an API key. It's basically the key to your Resend account so that you can send emails from your code. And make sure you never share this key with anyone, otherwise they can send email on your behalf. And you can save the file and close it. And now you're ready to send any emails to anyone. Now, just to show you an example of how you would do so, in the Resend documentation, there is something called API reference, and you can check they have something called send email right here, and they show you for a Node.js project how to send an email. And it's as simple as this. You would have to download their library, so npm install Resend, and then you import their object. Then you give the API key we just created to that object. So we have a client or a bridge to send email. And then with just these lines of code, you can send an email to pretty much anyone. Every developer/business owners have different needs on emails, but I wanted to show you a quick example of how I use emails for some of my apps. So here on the left, this is a file where whenever someone purchases one of my products, this code is being executed. There's a part where I send the customer an email, like a welcome email, to send them a unique link so that they can sign up to the app and also how to get started. And this here is a function that I created myself called send email. This is what you see on the right side. And so in this send email function, I am calling the typical Resend API we just watched earlier, where I pass from to subject, text, HTML, and a bunch of other things. And I export this function send email from this file so that anywhere in my app, I can just do await send email, the name of the email of the person, the subject line, and the content inside of the email. And I can send literally an email to anyone. And the part you're probably going to need emails the most is when people try to sign in using emails. They're supposed to receive a magic link when they click on this button. And for that, I am using the provider, the Resend provider from Auth.js, our user authentication library we talked about earlier. And with just this single line of code here where I give Auth.js the access to my Resend account through the API key, they are able to send an email to anyone who input their emails. Here that looks like this, where if people click, they will then be logged in, authenticated into our applications. In this case, you don't even have to customize the emails. You just have to have this line of code inside of your Auth.js file, and Auth.js is going to do all the work of crafting the emails, preparing the unique link for your customers to click on, and all you have to do is to give Auth.js your Resend API key. All right, now we are entering the most exciting part of the course, the part where we're gonna set up a little pricing system for our application. To charge money on the internet, you will need a payment provider. The two ones that are pretty famous at the moment are Stripe and Lemon Squeezy. I personally use Stripe, but it's not available for every country out there. For instance, if you're watching from India, you might have to settle for Lemon Squeezy because they will let you open a Lemon Squeezy account. Before we talk about the practical things, I want to give you a few unsolicited pieces of advice. The first one is that in order to open a Stripe account, you will need to have a business. That could be a freelancer business, that could be a legit company like an LLC or something, but you will need a business. Now, your business does not have to be in the country you're living in. You can have an offshore company. Be careful with that because it is very tempting to open a 0% tax offshore company in Delaware, USA. I've seen lots of people doing that, but you have to be extremely cautious with what your countries allows you to do or not, because in some countries you would have a double taxation. So you're going to be taxed 0% of your US company, but you will be taxed by your country on your US income. So be careful with these kind of things. You want to make sure you always ask ChatGPT where you live, what kind of business you're running, what kind of company you intend to open, and ask ChatGPT what are the rules, what is the double taxation saying about that. Make sure you do things really properly from the day zero because you really don't want to go into legal issues. The number one reason we're doing this internet thing is to have as most freedom as we can, and there's nothing worse than being engaged in some legal stuff, so do things properly from day zero. Okay, and another question I get asked all the time is how do I handle my Stripe accounts with the company? So I have one company that holds all the Stripe accounts for all of my businesses. So in my case, I have multiple businesses, and for each business, I have one Stripe account per business that is under the company name. And one final piece of advice about pricing for your software, your digital product, you always want to price a little higher than what you think is right, because it's a tendency I see in developers to underprice themselves. You're amazing, you're doing something that most people don't, you're shipping something on the internet, your time deserves to be paid well, so make sure you price your product well. Pricing is marketing. Those two are really correlated. I made an entire video dedicated to pricing. Add a link into the description if you want to watch it. That's going to help you choose your pricing system. Okay, now before we start coding our checkout and subscription system, we need to understand how Stripe or Lemon Squeezy is going to integrate with our software.
Both of the payment processing platforms are going to give us some kind of like user interface elements, such as like a checkout page where users can input emails and credit card, etc., that we're going to show to our client. This page is going to communicate directly with the payment processor, which is going to process the request, for instance, charge the credit card and create a subscription. And the payment processor is going to send us back some events to confirm what just happened. Something like that user just paid the invoice. We're going to tell the payment processor to send those events on our API, so we can update our database and do things like granting or removing access to the product for a specific user. We can also update the user information, etc. And in the background, our payment processor is also going to execute some other tasks. So for instance, if we set up a subscription, at the end of each month, the payment processor is going to try to charge that credit card of a user again without us having to do anything. Now let's dig a little bit deeper inside of the payment processor solutions. Those again, it's either Stripe or Lemon Squeezy, both are working in similar fashion. There are two main categories of things we'll touch. The first one is the product. So if we compare your software with a library of books, a product could be a book. It's the item or the service you sell.
And the price/variance, the price is the word in Stripe and the variance is the word in Lemon Squeezy, is like a version of your product. For instance, a PDF book, a Kindle version of your book, a physical version of your book, you get it. And the other part is the webhook events. Those are notifications or messages, whatever we want to call them, that are sent from the payment processor back to our server, our API, to let us know about some information that happened. For instance, a customer just paid the invoice, or the last payment of that customer failed, etc., etc.
Okay, so no matter if you are running a subscription business, a one-time payment digital product, or a advanced SaaS with metered usage, the payment flow is always very similar. There's a part where users can interact with your front end. So like, let's say they want to create a checkout, or they want to access their customer portal to update their billing information, cancel a subscription, download an invoice, etc. And there's another part called the webhook, where it's more like invisible things happening in the background. We're going to cover that later. So first, the part where people can interact with your system. For instance, like creating a checkout for one of your products. They will be able to click a button. This click will return a URL for, in my case, Stripe. And then here, people will be able to input their credit cards and subscribe to a plan that you have for your software, or just buy a digital product, for instance. This is usually done in two parts. There's the front end and the back end. The first thing you will need to do is to create a product in Stripe. In the case of the software I just showed you, I have a bunch of plans, so I have a bunch of products, but you could have technically just one. And then this is the code of what I just showed you one more time. This is a simple button, so you can see it's a React component that when people click, it's going to trigger this function, and this function is basically going to make a call to my API. And the API endpoint is right here on the right side. Here, first, I need to check if the user is authenticated, because I don't let people who are not authenticated to my app make a payment. And then I'm going to use the Stripe API to create a checkout. In the Stripe API call, I give Stripe the price ID of the product customers want to subscribe to. I also give a client reference ID, which is a unique identifier that I will use later in the webhook part, the invisible part, to retrieve information about that user. So that when Stripe tell me, oh, this customer just made a purchase, I know exactly which customer in my database that is. And then I get back a URL from Stripe, which I sent back to my front end. And in my front end, when I get the response, here I open a new window to that URL I got from Stripe. And this is why after clicking the button, customer end up on this checkout.stripe.com so that they can start a subscription for my app. In the case you want to have a customer portal, which I recommend, where customers can update their credit card information, they can download invoice, etc., you can use Stripe Customer Portal. It works exactly like the Stripe checkout. You make a call to the Stripe API, they're going to give you back a link, and they're going to create a page for your customers with all their information. So your customer will be able to see the credit card they use to make a checkout. They will be able to see their billing history. They will be able to cancel their plan, even change the plan, so that they can perform any form of billing settings.
This is great. We can create checkout for our users, but now you want to give access to the product to your users. For that, we're going to use the Stripe webhook events. So in the developer tab inside of the webhook part, you will be able to add webhook endpoints. A webhook endpoint is basically like a little API we're going to create to listen for events from Stripe. So for instance, when a person completes a checkout, we want Stripe to let us know inside of our webhook endpoint that customer XYZ completed a payment so that we can give them access to the product. When you add an endpoint, you have to add the URL of your API. So that could be domain.com/API/Stripe. And you have to choose the events you want to receive. They have really a bunch of events, I think over 100. So you want to select only the one that you need. Let's check the code for that. So for instance, this is one of the webhook endpoint for one of my software. I put it in the /API/webhook route. And here I have a simple function. This is just a regular API endpoint like we used to do previously. And in the first part, we want to make sure that this only Stripe can send us events. So we want to verify that the person making a call to this endpoint is actually Stripe. That's why there's a little part of the code here that Stripe will give you when you set up your account. We use that to verify the source of the event. And then we get the event data from Stripe. And we are going to iterate over which type of event. No matter what you are running, whether it's a software, it's a digital product, or no matter what, usually the checkout session completed is the number one event you want to listen for. This is the part where you would typically give access to your product. A checkout.session.completed means someone went to like a proper Stripe checkout, they input their credit card details and successfully completed the checkout. And if you remember remember from the previous part, when I created the checkout, I would give a client reference ID to Stripe. And now Stripe is going to attach this client reference ID to the data that I get from the event so that I can just use that to retrieve the user from my database. And in my case, what I do usually is I have an as access boolean on my database that is either true or false, and it becomes true only if the person has completed a checkout. To use the customer portal, that page where people can update their credit card details, etc., I also save the customer ID I get from Stripe inside of the user. And here you can do pretty much anything you want. You could send an event to the customer that say, thank you for your purchase. Here is the unique link to download the book you just purchased. You can literally, it's an API endpoint, so you can literally do anything you want. And if you're running a digital product, this checkout.session.completed type of event will get you as far as you want. Now, if you're running a more advanced, maybe a software with a subscription system, this checkout.session.completed same could be used in order to give access to the product. But now, if the person has canceled their subscriptions, they stopped paying or their credit card stopped working, you want to revoke access to your product. And for that, you can listen for the customer.subscription.deleted event. Here, Stripe again will send you some information about the customer, so they could be the client reference ID or they can be the actual customer ID. So you can retrieve the customer for your database. And what I do in my case is if the person has a deleted subscription, then I'm just gonna remove the as access. I'm gonna turn it to false. And in the front-end part, the visual part of my app, whenever they try to do something, I check if has access is true. If that's the case, I let them use my software. If not, then I just revoke access. I redirect them to the homepage, or I send them back an error that says you need to subscribe to my service in order to use it. Stripe really has a bunch of events that you can listen to. Don't go too crazy with it because it can become really complicated. Those two events will get you really far. There's another one that's really good for marketing, which is the checkout session expired, which basically if someone creates a checkout session but did not complete the session, so they abandon the cart, that's what they call it in e-commerce, Stripe will let you know that, and sometimes they would have include their emails and you can send them back an email that says, hey, I noticed you didn't finish the payment. You can ask them question why they didn't complete the payment, or you can then send them a coupon so they come back to your site or whatever. By now you have a pretty solid understanding of what you need to know in order to build a software. There is nonetheless a part that is pretty important about security. How to make your app secure to make sure that there is no data leaks or to make sure that the users has access to the right information, etc. Now you're lucky, after 2024, there are a bunch of AIs that are in your code that are going to help you understand if something is wrong or not. So what I really recommend you to do is to open a chat with an AI inside of your code base, give it access to the entire workspace, and then ask questions. So in this case, I ask a very basic question which might not cover everything, but you can ask AI to review your entire code and ask if there is a security issue somewhere, and you can go deep and ask specific questions. This is very important you do this because AI will be able to review the entire code base really quickly and able to flag some very important things, which is going to save you a bunch of headaches. There are a few parts that are important about security. In this case of our project, we have the one about React server versus client components. As we mentioned earlier, everything in this project is a React component, and by default, those components are server components, so they're rendered on the server where it's safe to do some kind of operations. And if we turn them into a client component by adding a use client at the top, then they are rendered on the clients. And so simply put, client components are not a safe space to do some sensitive operations. You want to use client components for stuff where people can click on buttons, but you want to make sure that in those clients components, you never perform some kind of operation like a database query, for instance. So make sure you always do database connections and all forms of sensitive operation, things that people should not be aware of on server-side components. In this case, this is the page that renders the dashboard you see on the right side. Here I have this little function that is going to retrieve the user data based on the session of the user. So I need to make a database connection and retrieve the user. And I have to make sure I do this operation on the server, so either on my computer or on the place my server is hosted on the internet, but never on the client side. Okay, we covered this a little bit earlier about environment variables. You want to make sure that your API keys, etc., are stored inside of .env.local inside of your computer, and add your environment variable on your hosting provider when you deploy your code on the internet. You want to make sure you use environment variables in order for your code to never be pushed accidentally on the internet. Here, for instance, if I do process.auth, the Stripe API key inside of these client components, this is a really terrible thing to do because every person who is going to see a page where there is a button delete dashboard component will be able to see the Stripe API key. So really don't do this. And then you want to have some form of controls on your API endpoint. So whenever a client, someone on the internet makes a request to one of your API endpoint, you want to have like a policeman or whatever this is that checks a few information about the person. For instance, have you logged into my app? Have you paid for the service? If you have paid, which plans are you on? You want to have like a set of control at the top of your API endpoint to make sure that you only allow a specific subset of users to perform some actions. For instance, this is the API endpoint here to create a record in my database, to create a new board like you see on the right side. Here, I'm checking a few things. If the body does not include a name, so the name of the board, I am rejecting this API endpoint. I also check if the user has a session, and if it does not, I'm going to kick the user out. And then I'm going to retrieve the user from the database, and I'm going to check if that person has access or not to my product, meaning has the person paid or not. And one more time, if it does not have access, then I'm going to reject this from the API endpoint to make sure that the code below is never executed. And finally, they're what developers call middleware, firewall, proxy. They have different names based on what you need, but basically they will be like a middleman between your client, people making requests, and your server. Because the client can be a malicious actor, and it does not necessarily have to be someone like a person on the internet, like a physical human, but they could also be a developer making requests to your API using a little script. And in that case, they could send like 1,000 requests to your API endpoint in 1 second. This is where you want to have like those firewall, proxy, or middleware that stands in between you and the server to make sure that the requests are only sent to your server if they match a certain conditions. For instance, you can block access to a certain country, or you can use a rate limiter that checks how many times this IP address has requested access to your API endpoint, and you can say like, if you have done this more than 10 times per minute, then I'm gonna block access. There really are a bunch of things you can do here. It can get really complex, but here you have a global understanding of one of the core concepts of security that you want to dig deeper when you deploy your application to make sure everything goes out safe. Before we talk about how to use AI to code super fast, we're going to go over a few advanced concepts that are not necessary for you to learn, but they're pretty handy and useful, and I will show you in some of my applications how I use each of them. So for Next.js, we have the dynamic routes. For instance, if I go over these tweets, you can see that it's under x.com marklus/status/ a unique identifier. And if I go to this other tweet of mine, it is the exact same URL, except that it has a different identifier in the route. This is basically a dynamic route. Twitter has built this like a structured page, like it's empty page, where if I go left or right, no matter which tweet I look, it's going to always look the same on the left, but the content inside the actual tweet will be different. This is called dynamic route. This is basically like you create those templates that are empty, like structures, and then you're gonna feed them the data. So it has a similar layout, but it has different content. This is very helpful if you do some things like SEO, for instance. And then talking about SEO, we also have Next.js metadata. So for instance, this is one of my websites. Metadata are things that are invisible to users, like here, the title of this website, the descriptions, and a few keywords, etc. Those are visible for search engines like Google. And so you want to make sure you have the minimum metadata for your app to be indexed and referenced by Google. Next.js makes it very simple when you export a constant called metadata with title, description, URL, whatever. They will automatically add those tags to your page so that Google can reference you. And finally, there are the loading screens. For instance, if I go to this page and I refresh the page, you're going to see that I will see this like state right now where I have those white cards because the page is actually loading. It's not necessary, but it gives a little clue to your user that something is happening when we're actually fetching the data from the database, so they have something to look at. All right, now we have advanced TailwindCSS classes, transition, group, opacity, shadow, border. All of them are pretty handy. They will help you make better designs. The hover one is probably what you are seeing right now when I'm hovering my mouse cursor on this card or that card. This is likely a hover effect from CSS, so you might want to learn some of them. About React, I think you learned pretty much a good chunk already. There is another hook you might have to use from time to time, which is
use ref, and you have this suspense component. For JavaScript, there are a few ones that are important. The local storage. This is like a mini database inside of your internet browser. So for instance, you can see this is one of my websites. It helps people make logos. So they can change the size of the logo, they change the icons, they can change the colors, etc. What I do as a developer, I put stuff inside of their local storage. Actually, if you open your developer tab, you will see inside of application, local storage, and here, CodeFast, I can see all those things here written are things that I add automatically with JavaScript to the local storage of my users. And for instance, this is where I save the actual settings of the person. So if I reload this page, I am going to see the exact same logo that I used to see because it's loading the information from my local storage. Okay, now it's pretty slow because my Wi-Fi is really bad, but there we go. It's loading this Apple again from my local storage. So people don't have to create an account because all the information is stored inside of their local storage. This is very handy when you do like free tools, marketings and stuff like that. We have not covered yet form validation. So when you have forms, like stuff where people can input stuff, you can let them input text. You can have like controls where here I'm saying that you can only have maximum 280 characters. So here I can press my keyboard, but nothing is happening. And then you have methods on arrays and objects like sort and find, which are pretty handy methods. Sorting will help you sort an array based on the certain conditions. Find to retrieve one item from an array. There are a bunch of helpers inside of JavaScript that's gonna make your life easier. Okay, I guess we are entering now the most exciting part of this video where we're gonna use AI in order to 10x your code output as a developer. Now, if you haven't followed the previous part of this video and you don't know yet how to build a little software by yourself, I really recommend you to do so before we start using AI to code for us, because AI is really good at explaining things to help you learn. But if you build stuff, if you use AI to write stuff that you do not understand, you will likely end up in like what people call the AI hell loop, where you're gonna be prompting an AI that will make first a good output that looks like you can make a bunch of stuff, but as soon as you get stuck a little bit, or as soon as you find bugs, etc., you'll spend hours prompting the AI to fix stuff, which is absolutely not fun. So learn the fundamentals by yourself and start using AI to 10x your output after that. Okay, the first step is to actually set up your AI coding agent inside of your code editor. At the moment recording this video, there are two great code editors. The first one is VS Code, which has an AI option with GitHub Copilot, this little guy here. Since it's free, I think this is where I recommend you to get started. And I am personally using Cursor AI. Both are very similar, so you can swap back and forth, you won't be lost. And then once you set it up inside of your code editor, you'll have to choose a LLM, a large language model. In my case, I use Claude 3.5 Sonnet. To be honest, don't overthink that. Pick the popular language models. So at this moment, GPT-4o is also very famous. So just pick one and let's move on to the next part. And now it is time to build a deep relationship with your AI. Let me show you what is my workflow with AI to code fast. Okay, now you are in your code editor, you have an AI. So basically you have like a software senior engineer that has the knowledge of your entire app. So you can ask the AI to do pretty much anything for you. I use this little like inline AI feature when I need to change one line of code. Usually this is what I do for CSS properties and styles. So for instance, this makes no sense, but I would say something like, add this CSS property to this div, and then I would just review the change and accept it or not. This also works super well if you go to the web and you like an SVG, like this little icon here. I like it, so I copy paste it into my code, but it is an HTML SVG, and I want to turn this into a valid JSX, so for React, and it's gonna do all the brain work of updating the right attribute so it's a valid JSX. Okay, now for anything that is more than just one or a few lines of code, I use the chat. You can press, I think, Command plus L to pop it up, and I use the chat for almost everything. As we have covered in a previous section, you can use it if you don't understand a part of the code, if you want to learn about a specific function, etc. It is very useful for education. It's also useful for brainstorming. Sometimes I have a feature idea in mind, and I ask the AI, how would you implement this feature? Here, this is just an example, but normally you want to give more instructions. And then you will see what the AI suggests here. I will just check what the AI had come up with that give me a little idea of how to implement it. Then I just keep chatting with the AI in order to get something that I think is worth it. And then of course, when I'm ready, I apply those changes to my code base and I review them step by step.
Something that is very important for this part is the context. The context is basically how much knowledge do you give to the AI about your code base. In this case, I gave the context of page.js, so this actual page right here, which for a big feature like this one, where I'm like adding a complete new feature to my app, is probably not enough. That's why sometimes you can just do this, like you press Command Enter, and you will give the entire app, all the files will be used as context for the chat with the AI. It's a little bit slower, but you will get better results. And you can also give like specific lines of code as context. So for instance, I can select this SVG and I can say add to chat, and now the AI knows exactly which lines of code I'm referring to, and it gets better results. All right, and another thing I love, which is called the composer in Cursor. If you press Command I, it's going to pop up this window that looks like the chat, but it's actually a composer. So you have access to like an AI agent. So it can run your terminal, it can create, edit files without you accepting or not. This is very powerful. You can do really a bunch of stuff, but it can also be dangerous because it goes really fast and it changes a lot of stuff. What I do usually, I use this composer thing when I know exactly what I want. For instance, I already have created some of the components I want to use, and I have exact, like clear instruction to give to the AI. I would use the composer. As you keep learning, you'll learn how to better prompt the AI to get the best result as possible. And you'll see that one thing that really helps is having a code base, like a template, like a code template that you reuse across your apps, so that the AI has already like a foundation, so it can add more code on top of it that is similar to your foundation. For instance, this is a little code base I built for myself about 1.5 years ago because I was making the same project over and over as a starting point. And now I always have like this code base, and whenever I start a new project, the AI already has some data, some files, some code to look at, so you can just write the code that is right for me. So there are a few things you want to consider to get the best results. First, you want to have the right naming. So you want to have like explicit names for your variables, files, and functions. So for instance, my API endpoints have a clear naming. For instance, the cron folder, this check status, or this fetch email for payments, this is explicit. So me as a developer, I understand what it means, and the AI can also understand what it means. In the same way, if I search for button in my files, all the React component I create that have a button will include the word button inside of the file. So if I search for button, I will find all the buttons I use in my app, and the words after explain a little bit about what this button does. So button checkout will create a checkout. The button name is also button checkout. So this gives more context to the AI. It's easier for the AI if I want to create a new feature that creates a checkout, the AI knows right away. There is another very powerful feature that you can use at the very beginning when you're getting started is AI rules. Those are a set of rules that we give to the AI developers in order for the AI to behave the way we want. So in Cursor, you can go to Cursor settings and then Cursor settings. And here you have this like a big text file where you can input anything you want. Those are basically rules that will be used by the AI to generate code that fits your needs. So in my case, I explain my tech stack. I'm using JavaScript, React, Node, etc., etc. So whenever I try new features, for instance, I want the AI to keep suggesting tools and tech stack that I use myself. Also, if you have some preference about how you use the libraries, sometimes there are frameworks like NextJS that builds features so fast that you want your AI to use the latest ones or the ones you use for all of your projects. This is where you can mention all of that right here. As of 2025, there is the 80-20 rule that I use, where 80% of the code is written by an AI and 20% of the code is written by me. So usually what I do is whenever I have something to build, the AI builds it first. It does the hard work of creating the components, writing the functions, etc. I keep prompting the AI until I refine and get a result that are pretty decent. Then I apply all my changes, and then me as a developer, I finish the last 20% by reviewing the code and polishing a few details on it until it works as I expect. Okay, and finally, this is pretty new, but this is absolutely awesome, especially for us developers who are not the best at designing, is how to use AI inside of your code editor to design for you. So sometimes I don't know exactly how the design should look like. So what I do is I find a design that I like, I just search for like the components I'm trying to design inside of Google. I'll pick an image that I like pretty much. So for a time picker, let's say I would go for this one, for instance. I would just take a screenshot of it. and I would give this screenshot to the composer. So right here, you have an option that says image, and you can upload a photo of the component you want. And I would add a little explainer of what I want. You can say, change the colors and make it as a primary orange or something. Build this component, name it whatever you want, and what should happen when the person clicks on buttons, etc. And then you submit, and the AI will give you something that usually is working pretty well. So learn how to become lazy and take parts that you like and just use the AI to code for you. Okay, I just added this little section here because I think it's important. These days, I see lots of developers mentioning tools like V0 and Lovable as the perfect place to start your project, and I don't think so. So in case you don't know what those are basically like web apps where you can input whatever you want, create a dashboard, create a sign-up page, a landing page for my app or whatever, and it's going to generate the entire code in front of you. And it builds some really absolutely beautiful components like those crypto dashboards, nice customer-facing dashboards, landing pages, etc. The output you get from just a little input of text is absolutely amazing. But it is also dangerous because it is not trained on your code, it is trained on the overall internet. It is going to output some code that you are not familiar with. It might use different libraries than the one you're using. It will have different design constraints than the one you're using. It will name your files, etc. differently than the one you typically do. And in the end, you're going to have to do a lot of rework in order to format this code to fit into your own project. So what I recommend you is to not use those tools, even though I love them, is to build something by yourself in your code editor. And then whenever you create a new project, reuse your code as a foundation, as a code base for your next project. And then you can use the AI inside of your code editor in order to write code for you, design components for you. You can upload those components, for instance, and you can tell the AI to fit the design constraints you've set up. And so it's going to create the same time picker, which will have the same border radius as your other components, will have the same color as your other components. It will name the file exactly like the way you name your other files, and you will have really few work to do on the AI outputs, and it's going to make your life much easier. And this is likely the end of the roadmap. Now, let me give you two quick pieces of advice before I let you build your apps. The first one is that I have seen hundreds of people making money on the internet, and they all have one thing in common. They all have a bias for action. They show up every single day and build stuff. Watching a video to learn how to code is great, but now taking your computer and starting to code your own project is even better. And second advice, do marketing. At some point, building app is really fun, but you will need some users to impact people's life to make a little bit of money, so eventually you can quit your job, and for that, you need to do marketing. 50% coding, 50% marketing is a good balance. I know marketing is hard, especially when you're a developer. That's why I'm gonna link below some articles that I wrote that I like marketing strategies that I've learned along the journey that helped me get a couple thousands of visitors on my site every single day. It goes from SEO, ads, copywriting, audience building, etc. Check out the description below, it is free. And that's it. I think it's about a 2 or 3 hours long video. So congrats for staying until the end. And also congrats to myself for finishing this video because it took me a lot of time. You probably have seen from my beard and my hair that went a little crazy that it took about a month or something. Also remember that there are no sponsors for this video. None of the tools I recommended paid me to make this video. The only sponsor of this video is myself because I have made a course called CodeFast to help people learn how to code from scratch, like what we've done in the roadmap, but more in details into each steps. Over 2,000 students love the course, so if you like this video, you might like the course as well. Now I want you to close this video, take your keyboard, start typing some JavaScript, buy a domain name, push it on the internet, and add a link below this video as proof of work. See you next time.